This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, based on the given statement, select the most appropriate option to solve the given question. So the question is, what will be the weight of 10 poles each of same weight? So if let us suppose one pole weight equals to x kg, then we have to find what is the value of 10x, which is the weight of 10 poles, such that it is given that each pole has same weight. Now we have two options, statement 1 and statement 2. Statement 1 is 1/4 of the weight of the pole is 5 kg. Statement 2 is the total weight of these poles is 10 kg more than the total weight of two poles. So the options are statement 1 alone is not sufficient, statement 2 alone is not sufficient, either statement 1 or 2 alone is sufficient, both statements 1 and 2 together are not sufficient. So let us see statement 1. It says 1/4 of the weight of a pole is 5 kg. Then what is the weight of a pole? Equals to 5 into 4, which is 20 kg. Then what is the weight of 10 poles? What is 10x? So 10x is 10 into 20, which is 200 kg. So we can say that statement 1 is sufficient. Now let us see what statement 2 says. Statement 2 says the total weight of these poles, which is 10x, is 160 more than total weight of two poles, which is 2x. So we get 8x equals to 160 or x equals to 20. So what is the value of 10x? 10x is 10 into 20, which is 200 kg. So using statement 2, we can also find out, which means either statement 1 or 2 alone is sufficient. So answer is option C. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, consider a function fx equals to 1 minus modulus of x, where the value of x lies between the range of -1 to 1, both included. The value of x at which the function attains a maximum and the maximum value of the function r. So if we get a maximum value at c, then we need to tell what is the value of what is c and what is the value of fc, like what is the point and what is that maximum value. Okay, so let us try to plot the graph. So how the graph of modulus of x looks like. So if we have x over here and modulus of x over here, then for positive values it will be a straight line, and for negative values of x it will be also a straight line but in the positive direction only. As for -3, we will get modulus of 3s plus 3. So it will look like this. Then how will it look for minus modulus of x? So if we have fx equals to minus modulus of x, then how will it look like? Then suppose we have 3, then for this it will become -3, and for -3 it will become 3. So for 3 it will become -3, so we have minus modulus of x. So for everything it will become negative. So for -3 also it will become -3. So it will go on like this. Okay, then how will it look like for 1 minus modulus of x? So for this it will shift by 1 in the upper direction. So for 1 minus modulus of x, it will look something like this. So if we have 1 over -1 over here, 1 over here, 0 over here, 1 over here, then for minus modulus of x, it will get shifted like this. Okay. Now it is for 1 minus modulus of x. Then what are the constraints? Constraints are that x can lie only in the range of 1 and -1, which means everything this won't occur and this won't occur. Only we will get the range between 1 and -1. Now we need to tell what is the maximum value. So maximum value is 1, which means fc is 1 and it occurs at a point 0. So answer is 0 and 1. Option C is correct, 0, 1. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, a generic term that includes various terms of clothing such as skirt, a pair of trousers and a shirt is. So we need to tell we have a skirt, a pair of trousers and a shirt. What is the generic term which can be used for all three of them? Let us see the options. What is a fabric? Fabric is basically a material which is used to make clothes. So it doesn't refer to the clothes, it refers to the material. Textile is basically a synonym for fabric, which also refers to the material. and not the actual clothes. Fiber. What is fiber? Fiber, if we have sheets of paper or cloth, then we compress them to make a leather-like substance which is called a fiber. So it's also a type of material and not these actual clothes. Apparel. Yes, apparel is the word. Apparel is basically the synonym for clothes. It's basically referred to a all the set of clothes can be called apparels. So answer is option D. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, choose the statement where the underlined word is used correctly. So statement A is, the industrialists have a personal jet. So here we have the word personal. So what personal means? Personal means it refers to an persons employed in an organization. Persons employed in an organization, or the workers of an organization are basically referred to as personnel. So, and there is another word, personal. Personal means related to an individual. So here instead of personal we should have a personal, as industrialists have a personal jet belonging to him own. So this one is wrong. I write my experience in a personal diary. No, it should be personal, as the diary belongs to that particular individual. All personal. Personal means persons employed in an organization or the workers of an organization are given the day off. Yes, this is correct. Being religious is a personal aspect. No, this is false. It should be personal. So A, B and D should be personals and C is correct. It should be personal. So where the underlined word is used correctly, so answer is option C. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, we dash our friends our birthday and we dash how to make up to him. So basically these guys have forgotten their friend's birthday and they don't know how to make up with him. But we have to see this forgot. What is forgot? Forgot is basically a verb. And what is completely? It's an adverb. So we need to tell what should be the sequence of them. So here it should be completely forgot. The adverb should come before a verb. So option D is wrong and option B is wrong. Now see, we completely forgot our friend's birthday and we. Now we have two options, just don't know or don't just know. So answer should be just don't know. As here also the adverb should come before the verb. So answer is option C. We completely forgot our friend's birthday and we just don't know how to make up to him. So answer is option C. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, in a triangle PQR, PS is the angle bisector. So PS is our angle bisector of angle QPR and QPS equals to 60 degree. Then what is, so we get angle QPS plus angle SPR equals to 120 degree. As it is angle bisector, thus this will be also 60 and whole will be 120 degree. Now see, now it is given what is the length of PS. So we need to tell what is the length of our side PS. So how will we do this? See, we know that both sine angles will be same. So we have sine QPS equals to sine angle SPR. So what is sine QPS? Sine QPS will be equal to our QS by R, QS by PQ, and it will be equals to SR by PR. So what is our QS by SR will be equals to PQ by PR. What is PQ is R and PR is our Q. Then what will be our value of QS by SR? SR can be written as P minus QR. P minus QR. It will be equals to R by Q. So doing cross multiplication, we get Q into QS equals to, it will be equal to P minus, sorry, this one SR. What will be our value of SR? It will be equals to P minus QS. P minus QS. So you get QQS equals to RP minus RQS. So taking QS on both the side as common, we get QS equals to PR by Q plus R. So this is our equation 1. Let me write it over here. So we get QS equals to PR by Q plus R. Equation 1. Now let us try to derive some more equations. Now we know that in a triangle A upon sin A equals to B upon sin B equals to C upon sin C. Now in our triangle QPS, how can we write this? We can write QS upon sin 60, which means QS upon this equals to PS upon sin Q equals to sin Q upon PS. So if we are triangle with this as A, this as B and this as C, and this as A, B and C, and this as A, small b and small c, then we can write A upon sin A equals to B upon sin C equals to C upon sin C. Similarly, for this we can write Q upon PS. See, we can write QS upon 60 equals to PS upon sin Q. Okay, then what will be our value of PS? So PS equals to QS into sin Q by sin 60 degree. We can make this as equation 2. Let me write it over here. So we get PS equals to QS into sin Q by sin 60 degree. Now let us try to derive some more equations. So now what we know? Now in this triangle PQR, we can also write the same equation. So how will it work? We will have P upon this side upon sin 120 degree equals to Q upon, which means this side upon Q upon sin Q. So what is our value of P? P equals to Q into sin 120 degree upon sin Q. Or we can write Q into sin 60 degree upon sin Q, as sin 60 and sin 120 has the same values. Okay. Now we have this as equation 3. So equation 3 can be written as P equals to Q into sin 60 degree upon sin Q. Now we have these three equations and we need to tell what is the value of PS. So what is our PS? PS equals to QS into sin Q by sin 60. Then what is the value of QS? QS, let us write it from over here. It's PR by Q plus R into sin 60 sin Q by sin 60 degree. What is our sin Q by sin 60 degree? It is equals to Q by P. So this is equals to Q by P. So what will it equal to? It will be equals to P and P will get cancelled. We will get QR by Q plus R. So answer is our QR by Q plus R, option B. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, out of the following 4 sentences, select the most suitable sentence with respect to grammar and usage. So let us see each sentence one by one. So sentence A is, since the report lacked needed information, it was of no use to them. So this one seems perfect to me. Let us see statement B. The report was useless to them because there were no needed information in it. See, it is there were no needed. No, it should be there was no needed information in it. So this is wrong. Let us see option C. Since the report did not contain the needed information, it was not really useful to them. No, it should be really useful to them. So C is also wrong. Let us see option D. So option D states B is wrong, C is wrong, A is correct. Since the report lacked needed information, it would not have been useful to them. No, it should be have been useful to them. So D is also wrong. So correct answer is option A, and all the corrections were word should be replaced with was, real should be replaced with really, and had should be replaced with have. So answer is option A. This question belongs to GATE CSE 2015's paper and the subject name is aptitude. So the question states, in the list of letters, PRSTU is an arithmetic sequence. So we have P, R, S, T and U being an arithmetic sequence. Which of the following is also an AP? So what is an arithmetic sequence? It means that all the consecutive terms will differ by the same common difference, which means R minus P will be equals to S minus R, which will be equals to T minus S, which will be equals to U minus T. Now we have 2PR, 2P, 2R, 2S, 2T, TU, which means each term is multiplied by 2. So whenever we multiply each term by 2, then this common difference will remain the same. Because suppose we multiply each of them by 2. Suppose initially it was 1, 3, 5, 7, 9. Then R was 2, common difference was 2. Now we multiply each by 2. Then we have 10, 14 and 18. Then the common difference also gets multiplied by 2. So if you multiply each of them by 2, then our common difference will be 2 into R minus P, 2 into S minus R, 2 into S minus R, 2 into T minus S, 2 into U minus T. Now since all of them have a common difference, they are also in AP. So which means multiplying by 2 do not change the arithmetic progression property of these terms. So this is an AP. Now let us see P minus 3, R minus 3, S minus 3, T minus 3 and U minus 3. If we subtract 3 from all of them, then in that case the common term will remain the same. Why? Because we have over here R minus 3 minus P minus 3. So we have R minus 3 minus P plus 3. So this plus 3 and minus 3 will get cancelled and we will get R minus P. Similarly, this and this will get cancelled, we will get S minus R. This and this will get cancelled, we will get T minus S. This and this will get cancelled, we will get U minus T. So this is also in AP. Now multiplying each term by square. So we have, now let us see whether R square minus P square equals to S square minus R square equals to T square minus S square equals to U square minus T square. What we have done, we have multiplied each term by square. So we get each term as square. Actually, this is not in AP. Why? Because let us suppose we have these terms 1, 3, 5, 7, 9. Now we multiply each of them by their square. So we get 1 square 1, 3 square 9, 5 square 25, 7 square 49, 9 square 81. Let us see the difference. 9 minus 1 is 8. But 25 minus 15 is, it's 16. And here it is 24. So the difference is not the same. So thus this is not in AP. So the correct answer is option 1 and 2 only are in AP. So answer is option B. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, if P, Q, R and S are distinct integers such that f of PQRS is the maximum value, g of PQRS is the minimum value among them, and h of PQRS is equals to remainder of P into Q divided by R into S if P into Q is greater than R into S, or remainder of R into S divided by P into Q if R into S is greater than P into Q. Now it is defining a function f g h of PQRS equals to f of PQRS into g of PQRS into h of PQRS. Also the same operations are valid for two variable function of the form P, Q, which means fg of PQRS is equal to f of PQRS into g of PQRS. What is the value of fgh of 2573 and 468? So let us break this out. So we have f of g, then we have h of 2573 comma 468. So it is like this. So first let us solve h of 2573. What is h of PQRS? So we have to tell whether 5 into 2, 10 is greater than 7 into 3, no. So its value will be equals to second part, R into S divided by P into 2, which is 7 into 3 divided by 2 into 5, which is 21 by 10. So remainder of this is 1. So its value will be equals to 1. So we will get f of g of 1, 4, 6 and 8. Now what is the value of fg of, so what is value of fg of 1468? So here we can use this two variable method. So it will be equals to f of 1468 into g of 1468. Now what is f of 1468? It is the maximum value of among them, which is 8. And g of this is minimum value, which is 1. So answer is 8 into 1, which is 8. So answer for this is 8. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, four branches of a company are located at M, N, O and P. M is in the north of N at a distance of 4 km. So M is over here, N is over here, and this distance is 4 km. P is in the south of O at a distance of 2 km. So this is our O, this is our P at a distance of 2 km. Let me also draw the map, direction map. So it looks like this. This is our north, south, west, east. This is northeast, this is southeast, this is southwest, and this is northwest. Now it is given P is in the south of O at a distance of 2 kilometers. Now N is in the southeast of O by 1 kilometer. So this is 1 kilometer. What is the distance between M and P? So we need to tell what is this distance between M and P. So how will we do this? So assume that this one is A, this is Z, and now let us extend it more. So assume this is Y, so this also becomes A. We know all these angles are 45 degrees. South and east have an angle of 90 degrees. So south is a bisector, so this is also 45 degree. Now what is sine 45 degree? Sine 45 degree will be equals to NZ, which is perpendicular, upon hypotenuse, which is ON. So 1 by root 2 equals to NZ is A and OZ is 1. So A equals to 1 by root. We got A equals to 1 by root 2. Now what is tan 45 degree? Tan 45 degree equals to NZ upon OZ, perpendicular upon base. Sin tan 45 is 1, NZ is A, OZ. So OZ is also A. So we got this as A. If this is A, this is A, then what is this? This is 2 minus A. Then NY is also 2 minus A. Now applying Pythagoras theorem in the triangle, MPY, we get perpendicular square, which is MP square, equals to hypotenuse square equals to perpendicular. What is our perpendicular? It's my square plus py square, which is base. So what is mp square? It's my. What is my? It's mn plus ny. What is mn? It's 4 plus what is ny? Ny is 2 minus a whole square plus py square. Py is a, so a square. So mp square equals to 4 plus 2 6 minus a whole square. It's a square plus 36 minus 12a plus a square. So what is the value of mp? Mp equals to under root of 2a square minus 12a plus 36. So this was 4 and this was 2a. So adding this we got 6 minus a. So this is 6 minus a and this square is this. Now applying the value of a, we get 2a square is 1 by 2 minus 12 by root 2 plus 36. So mp equals to under root of 37 minus 12 root 2 by 2, which is minus 6 root 2. So 37 minus 6 root 2. So if you solve this, you will get 37 minus 6 into what is root 2? 1.414. So you will get it equals to 5.34. So answer is option A, 5.34. This question belongs to aptitude subject and was asked in GATE CSE 2015. So the question states, an unordered list contains n distinct elements. So we have n distinct elements. The number of comparisons to find an element in the list that is neither max nor min is. So we need to find an item which is neither the maximum nor the minimum. as it is an unsorted list, unordered list with distinct elements. So if we sort it by any sorting algorithm, then it will take order of n log n comparisons at max. So then we will get a sorted list. Then we can return any item except the first and last item. So it will have order of n log n comparison. Can we simplify it further? Yes. Suppose we have list like this, unsorted, 8, 9, 53. Then instead of sorting it, we will select any three items we select from any range. Let us suppose we select this. Now using two comparisons, we need to just say whether which one is maximum and which one is second max and which one is third max. It can be done in two comparisons. So which means in constant comparisons, we will get to know who is the max and who is the min among them. So we will get 3880. Then we will return the minimum item. So it will take order of one comparisons. Why will this be guaranteed that it won't be minimum and the maximum? As if 8 was minimum, then it will come over here. And if 8 was maximum, then it will come over here. But 8 comes in the middle, which means it is neither the least item nor the maximum item. See, maximum item is 53. But 80 is also a possibility. But 8 can't be definitely the maximum item. As it is less than 80 and more than 3, so it can't be least. So our answer will be a middle item. So we just need constant comparisons for this. So answer is option B, order of 1. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, let R be a relation on the set of positive integers such that A related to B if and only if A and B are distinct, and let have a common divisor other than 1. Which means they have a common divisor other than 1. Which one of the following statements about R is true? So R is symmetric and reflexive but not transitive. R is reflexive but not symmetric, not transitive. R is transitive but not reflexive and not symmetric. R is symmetric but not reflexive and not transitive. Let us see reflexivity. A relation is reflexive if A is related to A. But here, see, it is on a set of positive integers such that A related to B if A and B are distinct. So, but here A and A are not distinct. So, reflexive property is not satisfied. Let us see symmetric property. Symmetric is satisfied if A is related to B implies B is also related to A. So, what A related to B means? GCD of A and B is greater than 1. And similarly, we can also write GCD of B comma A is greater than 1. Thus, we can write B is related to A. Thus, symmetricity is followed. Reflexivity is not followed. Transitivity. We can say that a relation is transitive if A is related to B and B is related to C implies A is related to C. Let us prove this with the help of a counter example. Is 3 related to 6? Yes, as it has 3 as a common divisor which is not equal to 1. Is B 6 related to 2? Yes, as it has 2 as common divisor which is not equal to 1. But can we say that 3 is related to 2? No, as it only has 1 as a common divisor. So 3 is not related to 2. Thus transitivity is not followed. So reflexivity and transitivity are not followed, symmetricity is followed. So R is symmetric but not reflexive and not transitive. Answer is option D. This question belongs to database management system subject and was asked in GATE CSE 2015. The question states, consider the following transaction involving two bank accounts X and Y. So we have two accounts X and Y. So what it does is read of X. It reads the balance of X. Does X equals to X minus 50, which means reduces its balance by 50, and write of X. So it updates the value of X bank account balance. Then what it does in Y is it reads Y. It does Y equals to Y plus 50 and then it writes Y, which means it increments its value by 50. So if its balance was X, then it becomes X plus 50. If it was X minus 50, if it was Y, then it becomes Y plus 50. So it's basically transferring rupees 50 from X to Y. The constraint that the sum of accounts X and Y should remain constant is that of atomicity, consistency, isolation, and durability. So what is atomicity? Atomicity means that if a transaction fails in between, which means either entire transaction should execute or none of the instructions should execute. Which means if it fails in between, then we should be able to redo the instructions, which means either all of these will execute or none of these will execute. What is the meaning of none of them will execute? Which means we will redo all the changes. So atomicity doesn't mean that their balance should be same. Consistency. Yes, consistency means that their initial balance, which was x plus y, should be equal to their final balance, which is x minus 50 plus y plus 50, which is equals to x plus y. So it is the property of consistency. What is isolation? Isolation means these transactions shouldn't interfere with each other if they are executed parallelly. What is durability? Durability means that the changes should be reflective, which means if there is any error in between, then we must be able to redo the changes. So the answer is consistency. Consistency ensures that the balance is consistent, which means the initial balance, initial amount equals to final amount. This is the meaning of consistency. So answer is option B, consistency. This question belongs to data structure subject and was asked in GATE CSE 2015. So the question states, a binary tree T has 20 leaves. The number of nodes in T having 2 children is. So what is a binary tree? A binary tree is a tree in which each node has at max 2 children, which means either it can have 2 children, 1 children or 0 children. This has 0 children, this has 1 children and this has 2 children, which means it must have at max 2 childs. For all node n, it should have at most 2 childs. So for solving this, there is a direct formula. For 20 leaves, it should have n minus 1. So for n leaves, it has n minus 1 nodes with 2 children. So answer is 20 minus 1, which is 90. But let me give you a proof for this. Let us suppose we have a binary tree like this, where some of the nodes are of degree 2, some of them are of degree 1 and some of them are of degree 0. Okay. So what are degree 2 nodes? This is a degree 2 node, this is a degree 2 node, this is a degree 2 node. So red represents degree 2, D2 node. What is a degree 1 node? This is a degree 1 node. Blue represents a degree 1 node. And what is a leaf node? Green one is a leaf node. So green one means leaf node or degree 0 node. Now, what is the sum of degree? Sum of all degrees, which is D, equals to number of leaf nodes are L. They have a degree 1. Number of D1 nodes. So these are D1 nodes. See, all D1 nodes have a degree 2. So D1 into 2. So we got 2 D1. Now, number of degree 2 nodes. So degree 2 node have a degree 3. So degree 2 node have a degree 3 except leaf node which has a degree 2. So we got minus 1 for leaf node. Now we got D equals to L plus 3D2 plus 2D1 minus 1. Now what is the number of edges? According to handshaking lemma, number of edges equals to degree by 2. Okay, and what are the total number of nodes? Total number of nodes n equals to degree 1 node plus degree 2 node plus leaf node. Thus applying this in this, we get number of edges equals to d by 2 equals to d2 plus d1 plus L minus 1. Okay, so now we know that, see, number of edges. What are number of edges? Number of edges equals to degree by 2. So number of edges equals to d by 2. And we know that number of nodes are this, d1 plus d2 plus this. So how we got this? We got this because for a node with n nodes, number of edges equals to number of nodes minus 1. So number of edges equals to number of node is d1 plus d2 plus L minus 1, and number of edges can be substituted to degree by 2 using these equations. So we got d by 2 equals to d2 plus d1 plus L minus 1. Now using this equation, this is equation 2 and this is our equation 1. So using equation 1 and equation 2, we can write L plus 3d2 plus 2d1 minus 1 by 2 equals to d2 plus d1 plus L minus 1. So we got d2 equals to L minus 1. So number of degree 2 nodes equals to number of leaf nodes minus 1. So we have 20 leaf nodes. So number of degree 2 nodes are n minus 1 or L minus 1, which is 19. So answer is 19. You can use the direct formula. N minus 1 is the number of nodes with degree 2 for total number of n leaf nodes. Answer is 19. This question belongs to software engineering subject and was asked in GATE CSE 2015. So the question states, consider the basic COCOMO model. COCOMO is constructive cost estimation model, where E is the effort applied by the person in months, D is the development time in chronological months, KCOL is the estimated number of delivered lines of code in thousand, and ABCD have their usual meanings. So ABCDE depends on the software being organic, semi-organic or embedded. The basic COCOMO equations are of the form. So for this, you can basically refer to this link which gives the information about the COCOMO model. So here, what is the effort? So effort is basically equals to A into KCOL to the power B. What is our development time? D is the development time. So development time equals to C into E to the power D, and people required equals to E by D. Okay, so what is our correct answer? Correct answer is option A. You can refer to this link for COCOMO model, which is constructive cost estimation model. Answer is option A. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, consider the following two statements. S1 gives, if a candidate is known to be corrupt, then he will not be elected. S2 is, if a candidate is kind, he will be elected. So let us assume C means candidate is corrupt, known to be corrupt, and E means candidate will be elected. Candidate will be elected. Then what is S1? S1 is, if the candidate is known to be corrupt, which means C implies he will not be elected. E dash or negation of E. S2 is, if the candidate is kind. Let us assume K is candidate is kind. Then K implies he will be elected. Now the options are, which one of the following statements follows from S1 and S2 as per sound inference rules of logic. If the candidate is known to be corrupt, then he is kind. C implies K. If the candidate is not known to be corrupt, negation of C implies he is not kind, negation of K. If the person is kind, he is not known to be corrupt, negation of C. If the person is not kind, then he is not known to be corrupt, negation of C. Now let us see S1. So what is S1? S1 is C implies negation of E. S2 is K implies E. What is X implies Y? X implies Y is equals to negation of X or Y. So S1 is equivalent to negation of C or negation of E. S2 is equivalent to negation of K or E. Now what does resolution rule says? If it says that if P or Q is true and negation of Q or R is true, if P or Q is true and negation of Q or R is true, then P or R is true. So if we assume negation of, if we assume this as P, so P or Q is true and negation of P or R is true, then which means Q or R is true, which means negation of K with P or R is true. So P is E, or if P or Q is true and negation of Q or R is true, sorry, the resolution rule doesn't say this. It says that if P or Q is true and negation of P or R is true, then Q or R is true. Then this is our P, this is negation of P, this is Q, this is R. So we have Q or R is true, which means negation of K or negation of C is true. Now can we write this as, what is negation of K or negation of C? Can we write it as K implies negation of C? Yes, as it will be equivalent to negation of this part, which is negation of K or negation of C. So answer is option C. If a person is kind, then he is not known to be corrupt. Option C is correct. This question belongs to Computer Organization subject and was asked in GATE CSE 2015. Question states, assume that for a certain processor, a read request takes 50 nanoseconds. So in case of cache miss, so in case of cache hit, we take 15 nanoseconds. And 5 nanosecond on a, in case of cache hit, we take 5 nanoseconds. And in case of a cache miss, we take 50 nanoseconds. Suppose that while running a program, it is observed that 80% of the processor requests result in a cache hit. So what is our hit rate? Hit rate is 80%. So what is miss rate? Miss rate is 1 minus hit rate, which is 100 minus 80%, which is 20%. Or it is equivalent to 0.80 and it is equivalent to 0.20. Then it asks what is the average read access time in nanosecond. So how it is organized? So we have a CPU over here, we have a cache over here, and we have a main memory over here. In case of a cache hit, like in 80% of the times, so what is our average time? Average time would be average equals to cache hit into hit rate plus cache miss into miss rate. So what happens is that 80% of the time cache will be hit. Cache will be hit 80% of the time, which means we will get our data in the cache. So what is the access time for this? It's 5 nanoseconds. And 20% of the time what happens is that data is not present in the cache. So we go to main memory and read our data, bring to cache and then read. So this entire time is our cache miss time, which is 50 nanoseconds. So this is equivalent to 40 by 10, which is 4 plus 10, which is 14 nanoseconds. So the entire average access time is 14 nanoseconds. So answer is 14. This question belongs to Computer Organization subject and was asked in GATE CSE 2015. So it states a system has 6 identical resources. So we have 6 resources over here. And n processes are competing over here. So we have n processes. Each process can request at most 2 resources. So it can request less than equal to 2 resources. Which one of the following values of n could lead to deadlock? Okay. See, if we have a single process, then all the resources are free. It can get both the resources, so there is no deadlock. If we have 2 processes, then again if both of them request all the resources, there are still resources left, so there is no deadlock. If we have 3 processes, then this one can request this, there is no deadlock. But in case of 4, assume that we have 4 processes. Then what happens? 1, 2, 3 and 4. So this requests this requests this requests this, and this requests this. Now 2 are left, so this one can request this and this one can request this. There can be no deadlock as this one P1, P2, P3 and P4 can execute as they have got both these resources, and then they will release and P1 and P2 will execute. But there is a possibility that P3 and P4 have some external dependency, like they are waiting for some other resources. Then in that case, there will be a deadlock. As 4 is the highest option, so we have no other choice than to select 4, as there may be some external dependency too. So answer is option D, 4. This question belongs to data structures subject and was asked in GATE CSE 2015. It states, consider a complete binary tree. So we have a complete binary tree over here, where its left and right subtree. So all the left subtree and all the right subtree is a max heap. So it is a max heap and it is a max heap. So what is a max heap? Max heap means each node value is greater than all left and right subtree values. Right subtree values. So suppose we have 10 over here. So 10 is greater than everything on the left. So here it might be 3, 2, 1. It's greater than everything, so it might be minus 5, minus 10, minus 30, and it will be minus 40, which means, see, 10 will be greater than everything on the left and right, minus 5 will be greater than everything on the left and everything on the right, minus 30 will be greater than, and this will be complete binary, which means all these will also be filled. Okay, the lower bound for number of operations to convert the tree to a heap is. So we need to convert it to a heap, either to a max heap or to a min heap. So how will we do this? First of all, let me tell you the process of removing a element from a heap. See, first of all, it is a complete binary tree. So its height is log n. Complete binary tree means all the levels will be filled and last level will be filled from left to right. Now consider a heap, max heap, 10, 50, 60, 30, 40, 10, 12, like this. Then it will have 13, 17, 3, 4, 8, 12. Now suppose we are removing this 100. So what we do? Let us suppose it's over till here only. Then we will bring this 8 over here, 8 over here, 100 over here, remove this, and then we will do heapify. So heapify, it will check it both its child, bring the greater one above, check both its child, bring the greater one above. So what is the complexity for heapify? It's order of log n, as log n is the maximum height of tree. So here also we can perform the heapify operation. So if we perform heapify operation, then it will take order of log n time, and it will convert both these, because these are already max heap. This is already a max heap. So it will convert both of them to a single max heap, including the node. So complexity is order of log n. We can also do this using a build heap method, but it will take order of n time. It's better to do in order of log n time, as just perform a heapify operation. Just one, perform a heapify at root, and it will convert the entire tree to max heap with a complexity of omega of log n. So answer is option A. This question belongs to compiler design subject and was asked in GATE CSE 2015. So the question states, in the context of abstract syntax tree and control flow graph, which of the following is true? So what is an abstract syntax tree? So during the compilation phase, we have steps: preprocessor, compilation, assembly, linking, and loading. What happens during compilation? During compilation, we have lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and target code generation. So during this syntax, when we are checking a syntax of a tree, then we are using abstract syntax tree. We are using abstract syntax tree to check whether a program is syntactically correct or not. And what is a control flow graph? So for a given block of statements, we draw a control flow graph to show like how there is a flow of statements in our program. Now let us see the options. In both abstract syntax tree and control flow graph, let node n2 be the successor of node n1. So n1 followed by n2. Then the input of a program, the code corresponding to n2 is present after the code corresponding to n1, which means n2 code should be present after n1 code. No, it is false. As if there is a loop, then n2 code can be present above the n1 code. Because there will be a loop. So in a control flow graph, there can be a loop, and this statement will become false. For any input program, neither AST or CFG will contain a cycle. False. In case of loops, control flow graph will have a cycle. The maximum number of successes of a node in abstract syntax tree and control flow graph depends on the input program. Yes, this is correct. For each node in abstract syntax tree and control flow graph correspond to at most one statement in a program. False. As see, in control flow graph, these are blocks, and a block can have more than one statement. So in a control flow graph, a block can have more than one statement. So at most one statement, this is false. So answer is option C. The maximum number of successors of a node in abstract syntax tree and a control flow graph depend on the input program. This question belongs to database management system subject and was asked in GATE CSE 2015. So the question states, with reference to the B plus tree index of order 1. So we have order of 1 for a B plus tree. Okay. So why is B plus tree used? It is basically used for indexing purpose. For indexing, B plus tree is used. The minimum number of nodes, including the root node, that must be fetched in order to satisfy the following query. So we have the query, get all records with a search key greater than or equal to 7 and less than 15. So we have this requirement. Make sure that this is only less than 15 and not less than equal to 15. Okay, so what we will do? We will first come to the root node, which is 9. So one node is referenced over here. Okay, we need to find the number of nodes. So one node. Then we know either we can search for 7 or we can search for 15. So let us consider first case when we are searching for 7. Then 7 is less than 9, so we will go to left. We will access this second node. Now we know 7 is greater than 5, so we will come to this middle part and we will access this node. Now we know its lesser range is 5, so we do not need to go to left. As on left, everything would be less than 5. And above range is 7, so we need to go on right. We come over here, yes. Now we know we need to get more than 11 values, so we need to go to right. Now we come over here. Now see, its upper range is 15, so everything on its right will be greater than equal to 15. But we need only less than 15, so no need to go to right. The number of nodes accessed are 1, 2, 3, 4 and 5. So we have accessed 5 nodes. Now let us consider second case. So second case is when we are searching for this 15. So first of all we are at this 9. Now we know 15 is greater than 9, so we go to right and come over here. Now we know we do not need to go to right as it is 17. So we need to go to middle part. So we come over here and access this. Now we know on right more than 15 are there, but we need only less than 15. So we go to the left part. We access this. Now we know on left less than 9 can be there. So we come to the left part. Now we know that on the left less than 5 will be there, but we need only greater than equal to 7. Thus we stop over here. The number of access in second case when we are searching for 15 is, here we are going from 7 to 15, here we are going from 15 to 7. The number of nodes accessed in this case is also 5. So answer to this question is 5. We can go in any method, 7 to 15 or 15 to 7, answer would be 5 only. This question belongs to software engineering subject and was asked in GATE CSE 2015. So the question states, a software requirement specification, which is a SRS document, should avoid discussing which of the following. So suppose we get a project. So first of all, a documentation is done. In documentation, we create an SRS document. In this, we will define what are all the needs of the client, and how we will proceed with the development. It is used during the development phase and during the testing phase and by the program managers. So here we will list down all the things that we would be using, what are the needs of the project, how it would be developed and so on. So let us see. User interface issues. Yes, they would be present in the SRS document. Non-functional requirements. Yes, functional and non-functional requirements both should be there. Design specification. No, design specification should not be there. Design constraints should be there. Like what are the constraints in the design? It is present in the SRS, but not design specification, because design specification is related to implementation and SRS is not a part of implementation. It's a part of documentation. Interfaces with third-party software. Yes, it should be present. Then which should be avoided? We should avoid the design specification as it is a part of implementation, not the documentation. So answer is option C. This question belongs to Computer Network subject and was asked in GATE CSE 2015. So the question states, identify the correct order in which a server processes must invoke the function calls accept, blind, listen and receive. So we need to tell the sequence in which these function calls are invoked by a server according to the Unix socket API. So these are the sequence. So basically this is our flow diagram for a TCP. So what happens is that initially TCP server will invoke these calls. It will invoke socket, bind, listen, accept and read. Read is same as receive call. So what is the use of each of the call? See, first of all we will do the bind call. So bind call will bind the socket to an address. Okay, we will have a socket. What is a socket? Socket is IP plus port. IP plus port sequence is called a socket. So it will be binded to an address. Then we will come in the listen state. So what here we does is that it wait for the connections from the socket. Then in the accept state, it accepts a connection to the socket. Then it blocks until connection from client is there. Then it comes to the read state where it receives the data from the connection. So the sequence is bind, listen, accept and receive. So answer is bind, listen, accept and receive. Option B is the correct answer. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, the larger of the two eigenvalues of the matrix 4521 is. So for this, first of all, we will find the characteristic equation. So what is the characteristic equation? It is A minus lambda I determinant equals to 0. A is our given matrix, so we have 4521 minus lambda is a constant and I is the identity matrix of the size of A equals to 0. So we get 4 minus lambda, 5, 2, 1 minus lambda, its determinant equals to 0. We get 4 minus lambda into 1 minus lambda minus 10 equals to 0. We get 4 minus 4 lambda minus lambda plus lambda square minus 10 equals to 0. Now we have lambda square minus 5 lambda plus 4 equals to 0. So solving this, we will get lambda square minus 6 lambda plus lambda plus 4 minus 10 is minus 6, sorry, minus 6 equals to 0. Taking lambda as common, we get lambda minus 6 plus 1 lambda minus 6 equal to 0. So the values of lambda are 6 and minus 1. These are basically the eigenvalues for our given equation or given matrix. So the larger eigenvalue is 6. So answer is 6. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, the cardinality of the power set of, we have a set S having the elements from 0, 1, 2 up till 10. So you have to tell the cardinality. So let us analyze it for a smaller set. So if we have a set with two items 0 and 1, then what is the power set of S? Power set of S has 5, which means nothing, only 0, only 1, and both 0 and 1. So the cardinality of a power set of two elements is 4. Cardinality of we have a general formula for a set of size n, its power set will have 2 to the power n elements. So here we have 0 till 10, which means 11 elements. So cardinality of power set of S, which is power set of S, is 2 to the power of cardinality of S, which is 2 to the power of 11, which is 2048. The answer to this question is 2048. So for a set of size n, its power set has a cardinality of 2 to the power n. So 2 to the power 11 is 2048. This question belongs to computer network subject and was asked in GATE CSE 2015. So the question states, which of the following statements is not correct about HTTP cookies? So let us see all the statements one by one. So cookie is a piece of code that have a potential. First, let me tell you what is a cookie. Have you observed that when you go to the Amazon.com website or Amazon.in website and add something to your cart, then if you close the browser and go again to the same cart, then you will see that that item is still added in your browser. It is still showing in your account. So how is it done? So it is done through the cookies. So the primary functionality of the cookies is to track the user browsing pattern. So it track your browsing pattern so that it can customize their viewing experience. So what is option D? Cookies can be used to track the browsing pattern of a user at a particular site. Yes, option D is correct. Now what basically is a cookie? So cookie is basically a file or a string. So cookie can be either a file or a string. Now cookies are basically criticized because it can violate the privacy. It can violate the privacy because it may be possible that we are browsing something and it is basically accessing that data. But it cannot compromise the security because cookie is just a data. See, cookie is just a data and not a code. Not a code. If it was a code, it can compromise the security, but as it is data, it can only violate the privacy. So cookie is a piece of code that has potential to compromise the security for an internet user. This is false. Now, cookies are basically passed through HTTP headers. In both cases, like when client contact server and when server contact lines. So the cookies gains entry to the user work area through HTTP header. Yes, this is correct. Now cookies can have various fields, like it can have domain, path, like where it had to go. It can have the content, and it also has an expiry related with it, like when that cookie will expire. So cookie has an expiry date and time. Yes. So the question is asking which of the following is not correct. So answer is option A. A cookie is a piece of code. First of all, it's not a piece of code, it's a data that has potential to compromise the security. No, it cannot compromise the security, it can violate the privacy. So answer is option A. This question belongs to programming subject and was asked in GATE CSE 2015. So the question states, consider the following function written in C programming language. So we have the function. The output of the above function on the input ABCD space EFGH is. So how the function looks like. Suppose we have stored A, B, C, D, E, F, G, H. Now what we are doing is that we are providing a pointer to this place. So how it works? So it has, see, there are two operators, double AND operator, not equal to operator. So not equal to has more priority than logical AND. So how it works is that we will have star A and star A not equal to blank. This is our if statement. So when this will if statement not execute, so it will break when either both of the condition are false, like any one of the condition is false, which means either star A equals to our null character or our star A is equals to blank, then this will break. So where will it break? So what happens? Initially we provided A. So is star A equals to blank? No, we have A over here and it is also not equal to null. So we will now increment A. So now we will come over here. So what happened? Initially it ran for A. Now A comes over here. Now it is not equal to null, not equal to blank, so it ran for B and come to C. Not equal to null, not equal to blank, so it comes to C. Now D is also not equal to null, not equal to blank, so it comes to this blank part. Now what happens is that A is equals to blank, so if won't execute. So if won't execute means this part won't execute and this function will stop. Now it will come to this D part. So D has executed this recursive call. Now it will do put char. So put char of D, it will print D. Now it will exit and it will come to C. C will do put char, it will execute and come to B. B will do put char, it will exit and come to A. A will do put char. So answer is D, C, B, A. So what it does is that it prints till the first blank or the null character in the reverse order. So answer is option D, D, C, B, A. This question belongs to computer network subject and was asked in GATE CSE 2015. So the question states, a link has a transmission speed of 10 to the power 6 bits per second. So bandwidth is 10 to the power 6 bits per second. It uses data packets of size 1000 byte. So packet size is 1000 byte or 8000 bits, as one byte has 8 bits, or let us write it as 1000 into 8 for simpler calculations. 1000 into 8 bits. Assume that acknowledgement has a negligible transmission delay. So transmission time for acknowledgement TTACK equals to 0, and it has a propagation delay. Propagation delay for acknowledgement as same as propagation delay for data, and assume that processing delays at nodes are negligible. Okay, and let us assume transmission time for data is given by TT data. Now what is, suppose we have a packet, what is transmission time? Transmission time equals to length of packet by bandwidth. So length is 1000 into 8 bits and bandwidth is 10 to the power 6 bits. So it is equals to 8 into 10 to the power minus 3 seconds. Or we can say 8 millisecond is the transmission time. But let us keep it like this only. 8 into 10 to the power minus 3. Now we have The efficiency of stop and wait protocol. So efficiency is 25% or 1 by 4. 25 by 100, which is equals to 1 by 4. So what happens in stop and wait? So we will have a packet, we will first transmit it, let it go to the receiver, we will wait for acknowledgement, and then we will transmit the second packet. So what is our efficiency? Efficiency is how much data we are transmitting. Data actually transmitted divided by total data that can be transmitted. Total data that could be transmitted. Okay, so we are transmitting how much data? So efficiency is 1 by 4 equals to, we are transmitting TT data. So we are just transmitting the data, TT data, as TT acknowledgement is 0. Okay, then how much can be transmitted? We can transmit TT data plus TP data, propagation for data, plus propagation for acknowledgement. Okay, so 1 by 4 equals to, let us assume it to be TT, it to be TT, and let us take, as both these are equal, they can be taken as TP. So TP plus TP is 2TP. Now let me simplify it further. So what is our transmission? 1 by 4 equals to, what is our transmission time? Transmission time we have calculated as 8 into 10 power minus 3. So it is 8 into 10 power minus 3 plus 2. What is about propagation time? Propagation time we do not know. Okay. So what can we do now? So we will do the cross multiplication. Let me clear all the stuff out. Okay, so we have 32 into 10 to the power minus 3 is equals to 8 into 10 to the power minus 3 plus 2 into TP. So we get 24 into 10 to the power minus 3 is equals to 2 TP, and we get TP equals to 12 into 10 to the power minus 3 second, or we have to tell in millisecond. So TP equals to 12 millisecond. So answer is 12 millisecond. This question belongs to Digital Logic Design subject and was asked in GATE CSE 2015. The question states, the minimum number of JK flip-flops required to construct a synchronous counter with the count sequence 0011223300 and so on is. So if we want to design a counter for the count sequence 0, 1, 2, 3. So it's basically then again 0, 1, 2, 3. So it is a mod 4 counter, and we need 2 flip-flop for it. But now we need 2 zeros, 2 1, 2 2s, 2 3s and 2 zeros. So we need to increase one more bit. So initially it was 0 0, then 0 1, then 1 0, then 1 1. Now we must increase one more bit. So adding a 0 in front of this, we get 0 0 0. Adding a 1, we get 1 0 0. Adding a 0 and 1 over here, we get 0 0 1, followed by 1 0 1. Then adding 0 and 1 over here, we get 0 1 0, 1 1 0. Adding a 0 and 1 over here, we get 0 1 1, 1 1 1. Then again over here. So it's basically a mod 8 counter and can be implemented using 3 flip-flops. But see here, so what is its binary equivalent? Its binary equivalent is 0 1 2 3 4 5 6 7. So it's not actually what we are planning to make. So what we will do now is that we will use 3 flip-flops and generate this given sequence. But when this sequence is generated, we will neglect the first bits. So we will neglect these bits and we will consider only we will neglect the MSB in each. So what will we get? We will get 0 0, 0 0, 0 1, 0 1, 1 0, 1 0, 1 1, 1 1, then again this. So it is done using 3 flip-flops. Similarly, only 3 flip-flops are needed. So what is its equivalence? Its equivalents in decimal are 0 0, 1 1, 2 2, 3 3, then again 0 0. So this is the same sequence. So it can be done using 3 flip-flops. 2 won't suffice because we will have 0 1 2 3 So we need to add another extra bit and neglect that bit in order to get 00, 11, 22 and 33. So answer is 3 flip-flops. This question belongs to compiler design subject and was asked in GATE CSE 2015. So the question states, match the following. So list A contains lexical analysis, parsing, register allocation and expression evaluation. And list 2 contains graph coloring, DFA minimization, post-order traversal, production tree. So what is register allocation? So we have a CPU. CPU has certain registers. So we need to assign the register to the variables. So this register allocation is done using graph coloring. So R is mapped to 1. What is expression evaluation? We would be given an expression. So either it can be written in pre-order, in-order, or post-order. Now all of this can be evaluated by using pre-order traversal, post-order traversal, in-order traversal. So expression evaluation can be done using post-order traversal also. Now what is parsing? So we have parsers. Lexical analyzers are called parsers. So syntax analyzers are called parsers. So what they basically does is that they use the production trees for parsing our given grammar. So Q is mapped to 4. Now lexical analysis is the first phase of the compilation. It is done using the finite automatas. So P is mapped to 2, DFA minimization. So correct mapping is 2413. So option C is correct. This question belongs to Theory of Computation subject and was asked in GATE CSE 2015. So the question states, consider two decision problems Q1 and Q2 such that Q1 reduces in polynomial time to 3-set problem. So Q1 basically reduces to 3 satisfiability problem and 3 satisfiability problem reduces to Q2. These reductions are in polynomial time and this one is also in polynomial time. Then which of the following is consistent with the above statement? Q1 is in NP, Q2 is NP hard, Q2 is in NP, Q1 is NP hard. Both Q1 and Q2 are in NP, both Q1 and Q2 are in NP hard. Okay. So first let me tell you the Venn diagram. So first we have the P set, then we have NP set, here we have NP hard set, and this intersection part is called NP complete. Now see what we are given. See, any less or equally hard problem can be reduced in polynomial time to 3-set problem. So if something is getting reduced, to 3-set problem, then this one is equal or less hard or less harder than 3-set problem. Now since Q1 is reducing to 3-set problem, which means Q1 is less harder than 3-set problem. Okay. Now this 3-set problem is an NP complete problem, which means Q1 will either be an NP problem or a P problem. Okay, because since 3-set is an NP complete, it is also NP. Now since it is also NP, so which means either it will be a P problem or a NP problem. Q, since Q is less than NP or equal to, so it will either be a P problem or a NP problem. And since P is a subset of NP, since here P is a subset of NP, so Q1 will always be an NP problem. So Q1 will always be an NP problem. It may or may not be an NP hard problem. Okay, now see. Now we have 3-set being reduced to Q2 in polynomial time, which means 3-set is less than or equal to harder than Q2, or Q2 is more harder or equal harder as 3-set problem, which means Q2 is also NP hard. Okay, Q2 is also NP hard, and it may or may not be in NP, but it will always be NP hard. So answer is option A. Q1 is in NP, Q2 is in NP hard. This question belongs to operating system subject and was asked in GATE CSE 2015. So the question states, a computer system implements a 40-bit virtual address. So we have a virtual address of, this is virtual address of 40 bits. What is a virtual address? So CPU always generates a virtual address. Page size of 8 KB. Now this virtual address is divided into two parts. First is page number, virtual page number, and another one is page offset. So what does page offset mean? Since we have a page, then we need to refer to a particular line of a page. So we need some bits in page offset. So how many bits do we need? See, page size is 8 KB, which is equals to kilobytes. 2 to the power 3 into 2 to the power 10 bytes, which is 2 to the power 13 bytes. So we will need 13 bits. So 13 bit is needed in page offset. So how many bits are needed in page number? We need 40 minus 13 bits. So 40 minus 13 is 27 bits over here. Okay, now see, let me clear this stuff out. Okay, and at 128 entry translation leukocyte buffer. See, this virtual address need to be converted to physical address for finding our data. So we have a data structure called TLB in between. So this is our TLB. It has various fields like whether a bit is valid or not, it's dirty or not. We have a valid field, we have a dirty field, then we have a tag field, and then we have the corresponding physical page number. So using this virtual page number, we will come to this TLB and we will find our physical page number. Okay, and when we get the physical page number, then we will create our physical address, which will have the physical page number, and we will have page offset. Page offset will be the same. Page offset will be the same, and physical page number we will get from here. And it will have 27 bytes, and it will have 13 bytes. Now let us read it further. The TLB is organized into 32 sets, each having 4 ways. So this TLB is organized into 32 sets. Set 0, set 1, set 2, and set 32. Okay, so since we have 32 sets, so 32 can be written as 2 to the power 5, which means we will need 5 bits for tag. So out of 27, 5 went for tag. So how many? See, out of 27, we need 5 bits for coming to a particular set. In this 27, see, we have this 27. Out of this 27, we will need 5 to go to our respective set. We will need 5. So how many are left for tag? So tag equals to 27 minus 5, which is 22 bits are left for tag over here. And here we will get a corresponding physical page number. Now it is asking, assume that TLD does not store any process ID. The minimum length of TLB tag is in bits. So we need to find the tag length. So tag length is 22 bits. Let me brief it up once more. We have a virtual address. We need to convert it into physical address. So virtual address has virtual page number and page offset. Since page size is 8 KB, which is 2 to the power 13 bytes, we will need 13 bits for page offset and remaining 27 bits for virtual page number. Using these 27 bits, we come to the TLB. TLB has a tag field and physical page number corresponding to the virtual page number. Now, since it has 32 sets, so we will, which is equals to 2 to the power 5, we will need 5 bits for getting to a particular set, and the remaining bits will be used for tag. So out of 27 minus 5, we will use 22 bits for tag. So answer is 22. Now we will get our physical page number and page offset. Now using this, we will go to our cache memory. Cache memory to see whether our data is present there or not. If it is present, we will give it to CPU. If not present, we will go to our main memory and get the data. Even if it is not present in the main memory, we will go to our secondary memory and get the data. So this is our flow. So answer is 22 bits for tag. This question belongs to programming subject and was asked in GATE CSE 2015. So the question states, consider the following C function. So we have the function over here. The return value of 1 of 5 is. So let us analyze the function. So it takes a parameter as n in the function fun. It initializes x to 1 and a variable k with a garbage. If n equals to 1, it returns x. Else it looks for k equals to 1 to k is less than n plus k, x equals to x plus fun of k into fun of n minus k, and return x. So let us try to derive the values. So what will happen for fun of 1? So we get n equals to 1. We initialize x to 1. If n equals to 1, return x. So x is returned, x is 1. So fun of 1 is 1. Now we have fun of 2. For fun of 2, we initialize x to 1 and a variable k to garbage. If n is n1, no. So for k equals to 1 to k is less than 2, which will it will run for only k equals to 1. It will do x equals to x plus, so what is the value of x? X equals to x, what is the value of x plus fun of k is 1 into fun of n is 2 to 2 minus 1. So we get 1 plus fun of 1 into fun of 1. It is equals to 1 plus 1 into 1, which is 2. Now let us see fun of 3. So what happens for fun of 3 is we initialize x to 1 and k to garbage. Now is n1? No, n is 3. Then we run this loop for k equals to 1, k is less than 3, which means for k equals to 1 and k equals to 2 it runs. So for k equals to 1 it runs, and for k equals to 2 it runs. So for k equals to 1, what it does is x equals to x plus fun of 1 into fun of 3 minus 1. And for x equals to 2, it adds to the same, to x it adds fun of 2 into fun of 3 minus 2. So you get its value equals to 1 plus fun of 1 is 1 into fun of 3 minus 1, which is fun of 2. Fun of 2 is 2 plus fun of 2 is 2 into fun of 3 minus 2 is 1. So fun of 1 is 1. So we get 2 into 2, 4 plus 1, 5. Now we have fun of 4. So what is fun of 4? So for x runs for the value 1, 2 and 3. So for x equals to 1, we get 1 plus fun of 1 is 1 into fun of, let me write it more clearly. We get 1 plus fun of 1 into fun of 4 minus 1 is 3 plus in the next iteration we add to the same for the value q, 2. Fun of 2 into fun of 4 minus 2 is 2 plus in the next iteration for k equals to 3 we get fun of 3 into fun of 4 minus 3, which is 1. So we get its value equals to 1 plus, so fun of 4 equals to 1 plus fun of 1 is 1, fun of 3 is 5, fun of 2 is 2, fun of 2 is 2, fun of 3 is 5, fun of 1 is 1. So we get 1 plus 5 6 plus 4 10, 10 plus 5 15. Now what is fun of 5? So we get 1 plus fun of 1 into fun of 4 plus fun of 2. We are just running this iteration. For k equals to 1 we get this. For k equals to 2 we get this. Into fun of 5 minus 2 is 3 plus fun of 3 into fun of 2 for the value of n to be 3. For n equals to 4 we get fun of 4 into fun of 1. Fun of 1 for n equals to 4. Now let us evaluate this value. So this value is, what is 1 plus fun of 1 is 1 into fun of 4 is 15. Fun of 2 is 2, fun of 3 is 5. Fun of 3 is 5, fun of 2 is 2. Fun of 4 is 15, fun of 1 is 1. So we get 1 plus 15 plus 5 into 2 10 plus 5 into 2 10 plus 15. 15 plus 15 30, 40, 50 plus 1 51. So we get the value to be 51. So fun of 5 is 51. This question belongs to Theory of Computation subject and was asked in GATE CSE 2015. So the question states, consider the following statements. The complement of every Turing decidable language is Turing decidable. There exists some language which is in NP but not Turing decidable. If L is in a language in NP, then L is Turing decidable. Which of the following is true? Only 2, only 3, only 1 and 2, and only 1 and 3. Let us see each of the options one by one. So first we have the complement of every Turing decidable language is Turing decidable. So when we say a language is decidable or a Turing decidable, which means there exists a solution to this in yes or no, which means either a string will be accepted or not accepted. Now, can we design a complement? So complement for this language, complement of L. Let us suppose L was decidable. Then complement of L, which is L dash. Can we say that a string will be accepted or not? Yes. Just reverse. For every yes, make it no, and for every no, make it yes. There are no changes that we need to do. For yes, we need to print no, and for no, we need to print yes. Because if a string is accepted in L, it would be rejected in L complement, and if it is rejected in L, it will be accepted in L complement. So yes, the complement of every Turing decidable language is Turing decidable. Let us see option 2. It says there exists some language which is in NP but not Turing decidable. Okay, what is a NP class problem? So NP class problem are those problems which can be solved in polynomial time, for which there exists a polynomial time solution, or can be accepted by solved by in polynomial time by a non-deterministic Turing machine. And what is this non-deterministic Turing machine? It is also an Turing machine. Okay, so thus this language is Turing decidable. So which means all NP languages are Turing decidable. So there exists some language in NP which is not Turing decidable. This is false. Let us see option 3. If L language is in NP, it is Turing decidable. We have already proved this. If L is in NP, it is Turing decidable. So this is also true. So answer is option 1 and 3 are only true. So option D is correct. Only 1 and 3. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, the number of divisors of 2100 is. So how will we find the number of divisors and number of factors? So the trick for this is, if we have a number n, and if we can represent the number n as product of prime factors. Any number can be represented as a product of prime factors. Prime factor 3, prime factor 2, prime factor y, 1 up to prime factor x. Let us assume prime factor n, it goes to prime factor n or any number prime factor z. And it has powers like this has power x1, this has power x2, this has power x3, and this has power xz. So number of divisors is equals to x1 plus 1 into x2 plus 1 up till xz plus 1. So it is equals to multiplication of 1 added to all the powers of the prime factors. Why? Why this happened? So 1 is added because we can multiply each of the prime factors 0 or more times. 0 or more times. So here 0 should also be considered. So 1 extra should come. So 1 this extra plus 1 signifies this 1 extra, which means 0 or more times the prime factor can be multiplied. So what is the prime factorization for 2100? So first we will have 2, we get remainder as 1050, then we have again 2, we get remainder as 525, then we have 3, we get remainder as 175, then we have 3, no we can't do with 3, we have 5, we get remainder as 35, then again we have 5, we get remainder as 5, 7, 35, we get 7. So 2100 can be written as, how can we write this? 2 square into 3 into 5 square into 7. So 7 to the power 1, 3 to the power 1. So number of divisors are 2 plus 1, this 2 plus 1 into 1 plus 1 into 2 plus 1 into 1 plus 1 for this. So it is equals to 3 into 2 into 3 into 2. So 3 is 9, 9 to the 18, 18 to the 36. So we get 36 divisors for 2100. So we just need to write the prime factorization and multiply by adding 1 to each of the powers of the prime factors. So answer is 36 divisors of 2100. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, in a connected graph, a bridge is an edge whose removal disconnects the graph. Suppose we have a graph like this. It is a connected graph with 7 vertices. let us suppose 8 vertices, then this edge is a bridge, because if we remove this, then this graph will become disconnected. Now this graph is disconnected. So this edge was bridge. Now let us see what it is saying further. So which of the following is true about bridges? A tree has no bridges. Okay. Is tree connected? Yes, tree is connected. So let me draw a tree over here. Tree won't have any cycle and would be connected. See, in a tree, every edge is a bridge. So tree do, because see, if we remove any edge, if we remove this, this becomes isolated. If we remove this, it becomes isolated. Any edge we remove, the graph will become disconnected. So every edge is a bridge. So tree has no bridges, it is false. Let us see option B. A bridge cannot be a part of a simple cycle. So if we have a simple cycle like this with 6 vertices, so can we have a bridge over here? Let us try to remove any vertex. So if we remove this vertex, does this become disconnected? No. Why? Because these two vertices still have another path. So in a simple cycle, every pair of vertex has two paths. And if we remove any edge, then the other path would be there. So if we remove this edge, then this path was already present. So bridge cannot be a part of simple cycle. This is true. Let us see option C. A edge of a click with size greater than or equal to 3 is a bridge. The click is a complete subgraph of a graph. So if we have a graph and inside we have a complete subgraph, let us assume a 4 vertices complete subgraph K4. So it looks like this. Now it is asking every edge is a bridge for a click. No, it is false. See, these two vertices have this part, but they have other paths too. So if we remove this edge, then they will still be connected by these two vertices. They can go through these two vertices. So they will still be connected by these n minus 2 vertices. So any edge you remove, path will still exist. So option D is also false. C is also false. Let us see option D. So option D states a graph with bridges cannot have a cycle. Okay, so which means if we have a graph having a cycle, so this is a cycle, then it can't have a bridge. Is it true? No, this is false. Assume this. Now if this edge is a bridge, because if you remove this, it becomes a disconnected graph, and thus this was a bridge. But this graph still has a cycle. So graph with cycle can have a bridge. So this is false. So which of the following is true? So answer is option D. A bridge cannot be a part of simple cycle, because if you remove any edge, still other paths would be there. So option B is correct. This question belongs to operating system subject and was asked in GATE CSE 2015. So the question states, consider 6 memory partition of sizes 200 KB, 400 KB, 600 KB, 500 KB, 300 KB and 250 KB, where KB refers to kilobyte. These partitions need to be allotted to 4 processors of size 357 KB, 2110 KB, 468 KB and 491 KB in that order. If best fit algo is used, which partitions are not allotted to any process? We have options 200 and 300, 200 and 250, 250 and 300, 300 and 400 KB. Okay, so first of all, let me draw the partitions. So partitions are of size 200 KB, 400 KB, 600 KB, 500 KB, 300 KB and 250 KB. Okay. And we get the process in the order 357 KB, then 2110 KB, then 468 KB, and then 491 KB. Okay, they arrive in this order. Now best fit algo is used. So what best fit does is that it scans all the partitions and allot the process to the partition which is closest to this number, which is greater than or equal to this 357 and closest, so that less space is wasted. So 357 will scan and find out that 400 is the closest. It can't come in 200, it can't come in 300, it can't come in 250, and 400 is the closest. So 357 kb will come over here, and some of the space will get wasted in internal fragmentation. 2110. 2110 is it can't come in 200. The next letter is 250. So 2110 will come over here, and some of the space is wasted in internal fragmentation. 468. 468 will come in 500, and some of the space will get wasted in internal fragmentation. 491. 491 will come in 600, and some of the space will get wasted in internal fragmentation. So 600 is being used, 400 is being used, 500 is being used, and 250 is being used, which are not allotted to any process. So 200 and 300 are not allotted to any process. So answer is option A, 200 kb and 300 kb. This question belongs to software engineering subject and was asked in GATE CSE 2015. So the question states, which one of the following assertions concerning code inspection and code walkthrough is correct? So what is code inspection and code walkthrough? So code walkthrough. Suppose we are developing an application. So code walkthrough is an informal meeting with our teammates or with the supervisors, or we can say the reviewers. So what they do is that they just review our code. Why it is done? It is done to get a feedback. So it is done to get a feedback, and it is an informal review meeting. So code walkthrough is usually carried out by an independent test team. No, it is carried out by a developer in the presence of reviewers. So this is false. What is code inspection? So code inspection is basically an formal review meeting. In this, we will test our code in depth. In-depth testing is there. In-depth inspection is there. And it is done to ensure the reliability, maintainability, and you can say the performance of the code, like whether it is optimized or not. So it is a formal review meeting and in-depth. So code inspection is carried out once the code has been unit tested. No, it's not necessary that after unit testing only we will do the code inspection. It can be done at any time. So this is also false. Code inspection and code walkthrough are synonyms. No, they are not the same. As you can see, they have a huge difference between them. Adherence to coding standards is checked during code inspection. Yes, we check coding standards are being followed or not during code inspection, so that the code becomes easily maintainable. So answer is option C is only correct and rest are false. This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, given below are some algorithms and some algorithm design patterns. So these are algorithms, these are the design patterns. Dijkstra shortest path, Floyd-Warshall algorithm to compute all-pair shortest path, binary search on a sorted array, and backtracking search on a graph. And patterns are divide and conquer, dynamic programming, greedy design, DFS, and BFS. Match the above algorithms on the left to the design paradigms they follow codes. So we have to match the algorithms to the design pattern. So what is a Dijkstra algorithm? So in Dijkstra algorithm, we will have a graph given. It can be directed. It is a directed or an undirected graph. And we need to find a single source shortest path. So distance from a particular source to a particular destination. We need to find this. And how it is done? So if we are at a particular source, we try to go to the shortest neighbor, the neighbor which is the closest or takes the lesser cost. So it's basically a greedy design. So greedy always try to choose the optimal path at a particular point of time. So Dijkstra is mapped to greedy. So first is mapped to 3. Then we have Floyd-Warshall. So Floyd-Warshall is basically all pair shortest path. What is the shortest path? From A to all other, from B to all other, C to all other, D to all other vertices, and E to all other vertices. And it uses dynamic programming to do the same. So Floyd-Warshall, which is second, is mapped to DP, which is 2. Now what is binary search? So we are in binary search on a sorted array. So we have been given a sorted array 20, 30, 50. So what we does is that we come to the middle item, and if we are searching, let us suppose 20, let us suppose 30. Then we see whether 30 is less than this or more than this. 30 is more than this. So we discard the left part and go to the right part. So which means here we are dividing the entire thing to two parts, and then we are going to any one part to solve the problem. So binary search is basically based on divide and conquer. Now we have backtracking search on a graph. So suppose we have a graph like this. So what is DFS and BFS? Suppose we have vertices like A, B, C, D, like this we have. So what is BFS? BFS means that we will go first breadth-wise, which means first we will go to A, then to all the neighbors of A, which are B, C, D, then to all neighbors of B, which are E, then to all neighbors of C, then to all neighbors of D, then to all neighbors of F. And what is DFS? So DFS will go depth first. It will go first to any depth. So let us suppose it goes to A, then it goes to B, then it goes to E, then it goes to F. And from here it does the backtrack. And then it goes to C, then to D. So backtracking is basically done by DFS. So fourth is mapped to our option 4. So answer is option C. 1 mapped to 3, 2 mapped to 2, 3 mapped to 1 and 4 mapped to 4. So option C is correct. This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, assume that you are provided with the following function declaration in C programming language. The declaration is int partition A. Here we are providing the array and here we are providing the size of the array. The function treats the first element of array as pivot. So first element is taken as pivot and rearranges the array so that all elements less than or equal to pivot are in the left part of the array and all elements greater than the pivot are in the right part of the array. In addition, it moves the pivot so that the pivot is the last element of the left part. The return value is the number of elements in the left part. The following partially given function in the C programming language is used to find the kth smallest element in an array of size n using the partition function. We assume k is less than or equal to n. So here we are having our algo. Now the missing arguments list are respectively. So we need to fill these two blanks. So let us understand the algo. So it is the kth smallest element. Here we are providing the array. Here we are providing the size of the array. Here we are providing the item that we need to find, the kth smallest item. So first, how does this work? So suppose we have our list like 20, 10, 30, 40, 70, 60, 50, 80. Let us assume it is like this, and 90 and 100, like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yes. So first element is taken as pivot and it is arranged to its perfect position. So suppose that first element was, let us suppose 40 instead of 100. Then what happens? So 40 is taken as pivot and arranged to its exact position. Then all items on its left will be lesser than 40. So 10, 20, 30 and all items on its right will be greater than 40. So 70, 60, 50, 80, 90 and 100. Okay. Now what will it return? So it is given that the return value is number of elements in the left half. So and pivot also comes in left half. So return items are 4. So return value is 4. So left hand comes out to be 4. Now how we are doing is that suppose indexing is like this 0, 1, 2, 3, 4, 5, 6, 7. Let me use a different color for array indexing. Let me use green one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what happens? Suppose if we are searching for if left hand plus 1 equals to k. So what is left hand? 4. If 4 plus 1 equals to k, which means we are searching for the fifth smallest element. Okay, if we were searching for the fifth smallest element, then we will directly return a of left hand, which means a of 4. 0, 1, 2, 3, 4. This will be the fifth smallest element, which means this is our base case. Okay, and if we are not searching for the fifth smallest element, if left hand plus 1 is greater than k, which means 1, 2, 3, 4, 4 plus 1 is greater than k. Let us suppose we are searching for seventh smallest element. So if left hand plus 1, which is 4 plus 1, 5 is greater than k. If 5 is greater than k, then we have to come on the left side. So in this case, let us suppose we are searching for second smallest element. Then what happens? We have 4 plus 1, 5. 5 is greater than k. So we need to come on the left half. Okay. Now we will fill these values. So if we are coming on the left half, then the array will start from this point. So what happens? We will just pass our array, and we need to pass the size of the array. The size of the array will be this only, 10, 20, 10, 30, 40. So we will pass here left hand, and we need to find the k smallest, second smallest element. It will remain the same. But suppose we are searching for the 7th smallest element. Suppose we are searching for 7th smallest element. Then what happens? Left hand plus 1 is less than equals to k. Which was left hand? 4 plus 1, 5. 5 is less than equal to 7. So what we do is that we will search our array from this point to this point. Okay. So what happens? Now our A was pointing over here, but now we need to move A over here. So how many part do we need to move? We need to move this entire left hand. So we'll A plus 1, A plus 2, A plus 3, A plus 4 plus 1, which means A plus left hand plus 1 we need to move. So we need to move A plus left hand plus 1 as it is the base address. Now the second part is the number of elements. So how many elements would be there? So the number of elements are 1, 2, 3, 4, 5. How do we come to this number? So this number is the total elements that were initially, number of elements that came in the left half plus this 70, which is n minus left hand plus 1. Then we have n minus left hand plus 1. Now we have to tell the value of the k, new value of k. Initially it was 7, but what is the new value? It is 6, 7. It will come at this index, 6 index. So how will we find this new value? This new value will be equal to the original new value that was present minus number of items that went to the left half minus 1. 7 minus 4, 3 minus 1, 2. This is the actual index for this. Okay. So we will find k minus left hand minus 1. So let us see the options. A left hand and k. A left hand and k. Okay. A left hand and k. And then we have A left hand plus 1, n minus left hand plus 1 and k minus left hand plus 1. So answer is option A to this question. It's basically the partitioning algo to find the kth smallest elements. It's a standard problem. So we do the partitioning and see whether we are at the correct index, whether the sorted position is the kth value. If not, we go to the left half or the right half based on the value of k. So answer is option A. This question belongs to operating system subject and was asked in GATE CAC 2015 set 2. So the question states, consider a typical disk that rotates at 15,000 revolutions per minute RPM and has a transfer rate of 15 to 10 to the power 6 bytes per second. If the average seek time of the disk is twice the average rotational delay and the controller transfer time is 10 times the disk transfer time, the average time in milliseconds to write a 512 byte sector of the disk is. We need to tell the time in milliseconds. So what is our average time to read or write? It comprises of basically three things. First one is average seek time plus average rotational delay plus effective transfer time. Now see, what is our rotational delay? We are able to perform 15,000 revolutions in 1 minute, which means 15,000 rotations in 60 seconds. So one rotation takes 60 divided by 15,000, which is equals to 4 by 1000 seconds, which is equal to 4 milliseconds. So our rotational delay is 4 milliseconds. So our rotational delay is 4 milliseconds. Now what is our average rotational delay? Average rotational delay is half of the rotational delay. So average rotational delay equals to rotational delay by 2, which is equals to 2 milliseconds. Now what is our average seek time? It is given that average seek time of the disk is twice the average rotational delay. So average seek time is equals to twice of average rotational delay, which is 2 milliseconds. So we get average seek time as 4 milliseconds. So we got average seek time and we got average rotational delay. Now let us calculate effective transfer time. So how will we calculate effective transfer time? What is our disk transfer time? Disk transfer time. See, we are transferring a 512 byte data at a speed of 50 into 10 to the power 6, 50 into 10 to the power 6 bytes per second. Bytes per second. So the time taken would be 0.0102 milliseconds. And what is our effective transfer time? So our effective transfer time, here it is given that the controller transfer time is 10 times the disk transfer time. So it is 10 times disk transfer time, which is 0.0102, which is equal to 0.102 millisecond. So average time of read slash write is equal to average seek time, which is 4 millisecond, plus average rotational delay, which is 2 millisecond, plus effective transfer time, which is 0.102 millisecond. So answer is 4 plus 2, 6.102 millisecond. And we can round off it to 6.1 millisecond up to 1 decimal place. Or you can also write 6.102. You will get answer for both. So answer is 6.1 millisecond. This question belongs to compiler design subject and was asked in GATE CSE 2015 set 2. So the question states, consider the intermediate code given below. Here we are given the intermediate code. The number of nodes and edges in the control flow graph constructed for the above code respectively are. So we need to tell what are the number of nodes and what are the number of edges in control flow graph. Okay. So first of all, for drawing the control flow graph, you should know what is a leader statement. So first of all, we will find the leader statement. So there are three conditions for leader. First statement is always a leader. Is always leader. Or we can say target of conditional or unconditional jump statement is a leader. And third condition is statement following the conditional or unconditional jump is a leader. Now let us see. See, the first statement is a leader. So this one is a leader. So leader we will mark by asterisk. Okay. Then we have the target of conditional or unconditional jump is a leader, and the statement following a conditional or unconditional jump. Here 9 is a conditional jump to 3. So 3 should be a leader as it is a target. And the next statement after 9 should be a leader as it is statement following a conditional jump. See, target of 11 is 2. So 2 should be a leader. And there is no statement following 11. So there is no other leader. Okay. Now we will draw the basic block. From one leader to another leader, we have a basic block. So first basic block would be only this one. Second one would be this. This will be B2. This will be B1. Third will be from here till 9. B3. B4 will be till here. Okay. Now what is a basic block? Basic block is basically a continuous sequence of code which do not have any branch statement. Either there will be inward branch or outward branch. There will be no branch in between a basic block. Now let us draw the basic block. So first we will have start, then we will have basic block B1, which will have the statement 1 only, which is I equals to 1. Then we will have basic block 2, which will have the statement j equals to 1. Then we will have basic block 3, which will have statement from 4 till 9. Then we will have basic block B4, which will have statement 10 and 11. Then we will have end. Okay. Now let us see the jumps. So the edges are the jumps. So we have a jump from 9 to 3. So we have a jump from 9 to 3 we have a jump. Okay. And we have a jump from 11 to 2. So we have a jump from 11 to 2. So what are the number of nodes? Number of nodes are 1, 2, 3, 4, 5, 6. 6 nodes and number of edges are 1, 2, 3, 4, 5, 6 and 7. 7 edges. So we have 6 nodes and 7 edges. So answer is option B, 6 and 7. This question belongs to Digital Logic Design subject and was asked in GATE CSE 2015 Set 2. So the question states, the number of minterms after minimizing the following Boolean expression is. So we have the Boolean expression f equals to d dash plus ab dash plus a dash c plus a c dash d plus a dash c dash d whole dash. Okay. Now let us see. Can we take c dash d as common in these two terms? Yes, we can. So we get d dash plus ab dash plus a dash c plus c dash d taken as common. We get a plus a dash whole complement. So what is x plus x complement? It's 1. So this becomes 1 and 1 into x is x only. So we get f equals to d dash plus ab dash plus a dash c plus c dash d whole complement. Now we have a distributive law. Distributive law of Boolean algebra. It states x plus yz equals to x plus y into x plus z. So here we have d dash and c dash d. So we have x plus yz. So we can write this as d dash plus c dash into d dash plus d. Then we have ab dash plus a dash c whole complement. Then we have f equals to d plus d dash. Here we have d plus d dash. D plus d dash is 1 and 1 into anything is that term only. So we get d dash plus c dash plus, we can write it as d dash plus c dash plus ab dash plus a dash c. Now again we can apply distributive law on c dash and a dash c whole complement. So we get this equals to d dash plus a dash plus c dash into c dash plus c plus ab dash whole complement. So we get f equals to d dash plus this is 1 and 1 into anything is that term only. So we get d dash plus a dash plus c dash plus ab dash whole complement. Now again distributive law is applied on a dash and ab dash. So we get this equals to a dash plus a into a dash plus b dash plus c dash plus d dash whole complement. Let me erase some of the things out. Okay. So now we have f equals to a plus a dash comes out to be 1. 1 into anything is 1 only. So we get f equals to a dash plus d dash plus c dash plus d dash whole complement. Now what is x plus y whole complement? X plus y whole complement is x complement into y complement. So we can write this as f equals to a double complement into b double complement into c double complement into d double complement. This is De Morgan's law. Now what is x complement? And its complement, it's x only. So we get f equals to a into b into c into d. This is our minterm, and the question is asking the number of minterms after minimizing. So after minimizing we get only one minterm. So answer is only one minterm. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015 Set 2. So the question states the number of onto functions, which is surjective functions from the set x equals to 1, 2, 3 and 4. So this is our x set, to the set y equals to a, b and c is. So what is a surjective function? So surjective function means that everyone should be mapped to something, which means a should be mapped to something, b should be mapped to something, c should be mapped to something, which means no one should be left out. Okay, there is no constraint on x. X elements can be left out, but y elements shouldn't be left out. So can you see that this problem is similar to distributing 4 different items in 3 different bins so that no bin is left empty. So how can we do this? So what are the total possible functions? So what are total function possible? They may be surjective, may not be surjective. So they are from a set of m, cardinality m, to set of cardinality n. It is 3 raised to the power 4, which is n raised to the power m. So we have total 81 functions possible. Now let us see which all functions are non-surjective or non-onto function. Okay, so see, a non-surjection can be due to the absence of a, like A may not be mapped to something, or B may not be mapped to something, or C may not be mapped to something, A, B and C. So we need to find F, A union B union C. So what is it equals to? It equals to A is not mapped to something, or B is not mapped to something, or C is not mapped to something, minus A and B is not mapped to something, minus B and C is not mapped to something, minus A and C is not mapped to something, plus all three are not mapped to something. So FA means, Fx means X not mapped. Okay. Now let us see all the terms. So F, A union B union C equals to FA. FA means A is not mapped. So we have just two choices and four things are mapped to two choices. So it is 2 raised to the power 4. B is not mapped to anything. So 4 things should be mapped to 2 things. It's 2 raised to the power 4. If C is not mapped, we have two choices A and B. 4 mapping to 2 is 2 to the power 4. Minus A and B not mapped to anything. So we just have C, 4 items mapping to 1 item. It's 1 raised to the power 4. Similarly, for B intersection C, it's 1 raised to the power 4. For A intersection C, it's 1 mapped to the power 4. Because they have 4 items mapping to 1 item. They have 4 items mapping to 2 items. They have 4 items mapping to 1 item. Now, all 3 are not allowed. So we have 4 items mapping to 0 item. 4 items mapping to 0 items. It's 0 raised to the power 4. So F, A union B union C, what it indicates? It indicates the total number of non-onto or non-surjective function. Non-onto function, cardinality of number of non-onto functions. They are 16 plus 16 plus 16, which is 48, minus 3 minus plus 0. So it's equals to 45. Now we have to find total number of onto functions. So total number of onto functions are, so we can write all the functions is a combination of which are onto and which are non-onto. So total are 81. 81 equals to number of onto functions plus non-onto functions are 45. So F onto functions cardinality is 81 minus 45. So what is it equals to? It's equals to 36. So number of onto functions are 36. This question belongs to Theory of Computation subject and was asked in GATE CSE 2015 Set 2. So the question states, which of the following is our regular languages? So L1 languages, W, X, W reverse such that X, W belongs to A, B whole star and W and X cardinality is greater than 0 and W reverse is the reverse of string W. So let us analyze L1. So L1 has W followed by X followed by W reverse. W reverse is the reverse of string W and the cardinality of W, X and W reverse should be greater than 0. So what is the minimum length possible? So all of them must have at least 1. So min length is greater than equal to 3 length is possible for this L1 string. So L1 length is greater than equal to 3. And the string belonging to L1 length is greater than equal to 3. Now see, W and X belongs to A, B whole star. So let us see a possible answer for this. So we can have A, B, B as W. Then X can be anything like A, B, A. And W reverse will be B, B, A. So this is W, this is X, this is W reverse. We need to find this. Now notice that X length is greater than 1 and W reverse are also greater than 1. But X can be any string over a comma b. So x can be this. So can x be this? Yes. Can x be this entire string? Yes. So can x be everything from here till here? Yes. X can be BB, ABA, BB. We can extend the length of x. Can x be extended all over? No. As w and x must have a length of greater than 1. W and W reverse. So which means we can shorten it down to extending W to the entire length and matching only the first and last characters. So what can be the updated L1? L1 is all strings of length greater than equal to 3 with same first and last character. This can easily be checked with the help of finite automata. Thus, this is regular. So, L1 is regular. Now, let us see what is L2. L2 is a to the power n, b to the power m, where m is not equal to n. So, we need to count number of a's and number of b's and check whether a is equal to b or not. And m and n are greater than 0. So, since a can be any larger length and b can be any larger length, so we need a stack to push a's, and we need another stack, and we need to pop a for each b, and we need to check whether a is equal to b or not. So it can't, as we need an extra memory, so it can't be done by finite automata. We can do it using deterministic push down automata, where we push for each a and pop for each b. So L2 is not regular, it is basically DCFL and needed a deterministic push down automata. Now what is L3? So L3 is a to the power p, b to the power q, c to the power r, such that pqr is greater than equal to 0. So it is any number of a's followed by any number of b's followed by any number of c's. Can it be done? Yes, it can be done. See, like this. We can have any number of a's. Okay. Then on epsilon transaction we come over here. Then we can have any number of b's. Yes. Then on null transaction we come over here. We can have any number of c's, and then we will accept this. So this is our NFA for this. So as we can draw the NFA, thus it is regular. And the regular expression is A star, B star, C star. Thus this is also regular. So answer is L1 and L3 are regular. Option A is correct. This question belongs to computer organization subject and was asked in GATE CSE 2015 set 2. So the question states, consider a processor with a byte addressable memory. So we have a byte addressable memory. It's given over here. Assume that all the registers including program counter, program status word, so program counter, program status word are of size 2 bytes. The stack in the main memory is implemented from memory location. So stack is starting from memory location 0100 hexadecimal, and it grows upward, and stack grows upward. The stack pointer points to the top element of the stack. The current value of stack pointer is, so we have stack pointer over here, which means stack is filled up till here, and stack pointer is pointing to 016E hexadecimal. The call instruction is of 2 words. The first is an opcode. So call instruction, first is an opcode, and the second is the start address of the subroutine. So opcode and address. One word equals to 2 bytes. So it is of 2 bytes and it is of 2 bytes. The call instruction is implemented as follows. Store the current value of program counter into stack. So program counter value, which is 2 byte, is stored into stack. So 2 byte is stored over here. Store the value of program status word into stack. So program status word, which is 2 byte, is stored above the program counter. So it is also 2 byte. The content of program counter just before the fetch of call instruction is 5FA0. So before the fetch, its value is 5FA0. After the execution of call instruction, the value of stack pointer is. So we need to tell the value of stack pointer. Since the call instruction first stores the value of program counter into stack, so and as program counter is 2 bytes, which means we will store the program counter in stack and it will increase by 2 bytes. So current value of stack pointer is 016E plus 2 bytes. Now we store the value program status word registered in stack. Since program status word is also 2 bytes, which means we store the program status word in stack and it will also increase by 2 bytes. So it will be equal to 016E plus 4 bytes. Now what is 016E? So 016E is 0000 plus 0001, 6 is 0110, E is we have A, B, C, D, E. It's 10, 11, 12, 13, 14. So E is 14, so it will be 1, 1, 1, 0. Yes. Now it will increase by 4 bytes. So it will increase by 0, 1, 00. So we will have 0, 1, 1 plus 1 is 0, carry over 1. 1 plus 1 is 0, carry over 1. 0, 1, 1, 1. 0, 0, 0, 0, 0, 0, 0, 1. So it is equals to 0, 1, 7, 2, base 16. So answer is option B, 0172 base 16. This question belongs to Theory of Computation subject and was asked in GATE CSE 2015 set 2. So the question states, the number of states in the minimal deterministic finite automata, which is minimal DFA, corresponding to the regular expression. What is our regular expression? It's 0 plus 1 whole star 1 0. So we need to find number of states in the DFA for this. So this is set of all possible strings followed by 1 0. So what is our language? So L represented by this regular expression is set of all strings ending with 1 0. So how will we draw the DFA? So we will have a state Q1, with a 1 we come to Q2, with a 0 we come to Q3. We must accept it, so it is final state. Now what happens on a 0? We loop over here. Here on 0 we go over here, on 1, since 1 is making no progress, we come to here only. Now here on 1, since we have made 1 progress, as out of 1 0, on seeing a 1 we have made a 1 progress, so we come to state Q2. On seeing a 0 we have lost all the progress, so we must come over here. So number of states required are 3 states, so answer is 3. This question belongs to Computer Network subject and was asked in GATE CSE 2015 set 2. So the question states, host A sends a UDP datagram consisting of 8880 bytes of user data to host B. So we have host A sending some data to host B. So the total data that is being sent is, so we have layers over here. We have physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. So from these layers we need to send 8880 bytes of data. Ethernet frames may carry up to 1500 bytes. So their MTU is maximum transmittable unit is 1500 bytes for Ethernet. Size of UDP header is 8 bytes. So at transport layer, we add a UDP header of size 8 bytes to this 8880 bytes. So total comes out to be 8888 bytes. Is the total amount of data which is transferred to network layer. Now size of IP header is 20 bytes. So out of this 1500 bytes, 20 bytes will be our IP header and 1480 bytes will be our IP payload. Okay. There is no option field in IP header. How many number of IP fragments will be transmitted? So we need to find number of IP fragments. And what will be the content of offset field of? We need to find offset field of last fragment. Okay. So what happens? Let's see. So total data is 8888 bytes. The number of fragments is, total data is 8888 bytes, but only effectively 1480 bytes can be transferred in one fragment. So we have its upper bound, because if it's 6.5, then we can't use a 0.5 fragment. We need to use entire one fragment. So it's equivalent to its upper bound, which is 7. But this value comes out to be 6.005 upper bound, which is equal to 7 fragments. So we use 7 fragments. Now what is offset field of last fragment? Last fragment. See, all these 6 are complete. So each fragment is transferring effectively 1480 bytes. So 6 fragments will transfer this. So how much can be transferred? 1480 into 6. We are transferring 8880 bytes. And the rest is left out. So what offset states? So offset tells how many. So offset of last fragment will tell how many bytes of data has been transferred before this. So we have transferred this much amount of data before last fragment, but we need to scale each of this by 8 because of the size constraint. Always, which is it is scaled by 8. So we got 1110. So offset field of last fragment is 1110, and 7 are the number of fragments. So answer is option C. This question belongs to computer network subject and was asked in GATE CSE 2015 set 2. So the question states, consider the following routing table at an IP router. So we have next hop, subnet mask and network number. For each IP address in group 1, identify the correct choice of next hop from group T to be using the entries from the routing table. So we basically need to route these IP addresses using this table and tell the next hop, corresponding next hop. So let us see the IP addresses one by one. So first IP address is 128.96.171. So 171 is 10101011.92. So what happens? You will take the IP address and do AND with the subnet mask, and if it matches with any network number, we will send it to that corresponding hop. And if it do not matches with any, we send it to the default, which is R4. And if it matches to more than one, then we send to the longest matching one. So first we do the AND with 255.255.254, which is 11111110.0. So what we get? We get 128.96.10101010.0. So what is its equivalent to? It's equivalent to 128.96.170.0. Is it matching with this? Yes. So it is sent to interface 0. So first is sent to interface 0. Interface 0. Now let us see the second IP address. The second IP address is 128.96.168.0. So we have 168.0. What is the binary equivalent for 168? It's 10100111. Now we have, the second IP address is 128.96.167.151. So we have 167.151. So 167 is 10100111.151. We do the AND with the first IP address. We'll start checking from up till down. Then we have 255.255.254.0. So the AND comes out to be 128.96. So this one comes out to be 10100110.0. So what is its equivalent to? It's equivalent to 128.96. It's equivalent to 166.0. Is it matching? No. So this one is not matching. Then we do the same. So its network mask is same. Is it matching with this? No, it is not matching with this. So we have 166.0. So is it matching with this? No. Is it matching with this? Yes. So it is forwarded to interface R2. Okay. Now let us do for the third IP address. So third is 128.96.163.151. So we have 163 over here. So what is the binary equivalent for 163? So for 163 we get the binary equivalent as 10100011.151. So we first do the AND with 254.0. So what we get after doing the AND? After doing the AND, we will get 128.96.10100010.0. It's equivalent to 128.96.162.0. Is it matching with first one? No. Matching with second one? No. Matching with third one? No. Not matching with anyone. So then we do the AND with this 255.255.252.0. So 252 is 1100. So we 1 2 3 4 5 6 7 8. Yes. So after doing the AND, we will get, what we will get is dot 10100000 1 2 3 4 5 6 7 8 dot 0. So it's equivalent to 160.0. So it is not even matching with the fourth one. So it is sent to the default one. So default one is interface R4. Now let us do for the fourth IP address. It's 128.96.164.121. So 164 equivalent is, let me clear this stuff out. So what is 164? So 164 is 10.100.121. Now it is first checked with 254. It is 11111110.0. So what the AND comes out to be? It comes out to be 128.96.10100.0. So it's equals to 164.0. Is it matching with first one? No. Second one? No. It's matched with third one. Not with even with third one. It matched with fourth one, which is interface R3. So first is mapped to 0, which is option A. So first is mapped to A. Second is mapped to C. Third is mapped to R4, which is E. And fourth is mapped to R3, which is G. So it's ACET. So correct answer is option A, ACET. This question belongs to Database Management System subject and was asked in GATE CSC 2015 set 2. So the question states, consider two relations R1 A, B with the tuples 1, 5 and 3, 7. So we have R1, let me draw it over here. We have R1 with the attributes A and B, and the entries are 1, 5, 3, 7. So we have 1, 5 and 3, 7. And R1 A, C, we have another relation R1 A and C as attributes with 1, 7 and 4, 9 as the entries. Suppose that RABC is the full natural join of, so this is R2, sorry, this is R2. So R1 ABC is the full natural join of, we have RABC, ABC is the full natural join of R1 and R2. So R is R1 full natural join of, this is a symbol for full natural join of R2. So what is a full natural join? It is nothing but left outer join union right outer join. Left outer join union right outer join. Now what is left outer join and right outer join? Let me tell you. So this is left outer join. So what we do is that we write all the attributes and then we first do the natural join. So natural join is done on common attributes. So R1 has A as common and R2 has A as common. Okay. So let us write 1 and 5. Is one matched to any one of this? Yes. 1, 7. So C is 7. Do we have any one entry? No. Now 3, 7. So is 3 matched to any entry of A of R2? No. So this is our natural join. Now left outer join means any entry. So see, 1, 5 was utilized, but 3, 7 is left. So we must write 3, 7 along with a null entry in C. This is left outer join. Now what is right outer join? It has attributes A, B and C. Now what we do over here is, first we do R1 natural join R2, which will give us 1, 5 and 7, as 1 is mapped to this one. But now see, 3 is not mapped to anything, and here 1, 7 is mapped to 1, 5. So 1, 7 is mapped to 1, 5. But 4, 9 is not mapped to anything, because 1, 5 got mapped with 1, 7 and 3, 7 doesn't got mapped with anything, and 4, 9 also doesn't got mapped with anything. So here we write the elements of R2 which are not mapped to anything. So we write 4, 9 and null in B entry. Now full outer join is basically union of left outer join and right outer join. So we have 1, 5, 7, 3, 7 null, 4 null, 9. Now let us see which are matching. So we have 1, 5, 7, which is E, we have 3 7 null, which is F. We have 4 null 9, which is G. So we have E F G. So R contains E F and G, but not A B C D. So R, this is true. R contains E F G, but not A B. So option C is correct. This question belongs to Database Management System subject and was asked in GATE CSE 2015. So the question states, consider a simple checkpointing protocol and the following set of operations in the log. So we have these operations and a checkpoint. Now if a crash happens now and the system tries to recover using both undo and redo operations, what are the content of the undo and redo list? We have the following 4 options. Now let me first try to draw the transaction map for this. So transaction map will have T1, T2, T3 and T4. We have these 4 transactions. Now start is represented by S, write is represented by W, and commit is represented by C, checkpoint is represented by an asterisk, and crash is represented by cross mark. So first we have start of T4, which means S, then write of T4 W, then start of T1 S, then commit of T4 C, then write of T1 W, then we have a checkpoint represented by asterisk. Okay, then we have start of T2 represented by S, write of T2 represented by W, commit of T2 represented by C, start of T3 represented by S, write of T3 represented by W, and then we have a crash. So now what is a checkpoint? So checkpoint is basically a mechanism where all the previous logs, see here we are maintaining the logs, write T1 Z, 5, 7. So we are maintaining it, 5 has been updated to 7, the Z value which was initially 5 has been updated to 7. So after a checkpoint is basically a point where all the previous logs are removed and the system, and they are stored permanently in our storage disk. So checkpoint declares a point before which the database was in consistent state. So over here the database was in consistent state. Now recovery management system reads the log backward from the end of the last checkpoint, and it maintains 2 lists. We have a redo list and a undo list. Now all the transactions which have a start followed by a commit or just a commit are stored in the redo list, but we must make sure that they should be after commit. Like if we have both start and commit, then they are added only after checkpoint. And we have an undo list. In undo list, all the transactions which have a start but no commit are added in undo list. Now let us scan. T1. T1 has a write but it has no commit, so it is added in the undo list. Now we have T2. T2 has a commit but the commit is present after the checkpoint, so it is added in the T2 list, redo list. Now we have T3. T3 has an uncommitted write, so it is added in the undo list. Now we have T4. T4 has a commit after a write, but it is before the checkpoint, so there is no need to add it in the redo list. So we have undo of T3 and T1 and redo of T2. So option E is correct. This question belongs to operating system subject and was asked in GATE CSE 2015 set 2. So the question states, a computer system implements a 8 kilobyte pages and a 32-bit physical address space. Each page table entry contains a valid bit, a dirty bit, 3 permission bits, and the translation. If the maximum size of page table of a process is 24 megabyte, then the length of virtual address space supported by the system is how many bits? Okay, so see how this system works. So basically we have a process. This is our process, and for accessing any entry we need a virtual address, but this can't come in an entire space. So what we do is that we bring some of the pages, we divide this into frames, pages and main memory into frames, and pages are brought into frames. So this is our main memory, and we have a page table for the translation. We have a page table. So we have a CPU over here. CPU always generates a logical address, or you can say virtual address, and then we have the translation mechanism using page table to convert the virtual address into physical address. Here it is converted to physical address, and then the corresponding data is searched in main memory. If it is not present, it is basically brought from secondary memory to main memory using the page miss mechanism. Now let us see what the question is saying. So it is saying that we have 8 kilobyte pages. So this virtual address is basically divided into two parts: page offset and page number. Similarly, our physical address is divided into page number and page offset. Since page size is 8 KB, which is equals to 2 to the power 13 bytes, thus we will need 13 bits for offset. So offset is our 13 bits. And this page number and this page number are different. This is, let us suppose it is page number and this is page number dash. So the entire physical address is 32 bits. It's given over here that the entire 32-bit physical address. So what is the length of the page frame bits? Or we can write this as page frame bits. So page frame bits length is equals to 32 minus 13, which is 19. Okay, so we have 19 bits for page frame bits, 19. Now each page table, what each page table has? It has one dirty bit. Each entry has one dirty bit, one valid bit, 3 permission bits, and the translation. So translation is basically based on the page frame bits. So it's 19. So 19, 3, 20, 22 plus 2, 24 bits. So basically each page table entry is equals to 24 bits. Okay, which is equals to 24 by 3, which is equals to 8. 24 by 8, which is equals to 3 bytes. So 3 bytes is the size of each page table entry. Now what it is given that the maximum page table of a process is 24 bytes. Okay, so let me first clear some of the stuff out. Let me also clear this. Yes. Okay. So what is our? See, we have a page table of size 24 megabyte maximum, and each entry is of size 3 bytes. So number of page table entries is equals to page table size, which is 24 megabyte, divided by each entry size, which is 3 bytes. So we have 8 million entries. So we have 8 million entries in a page table. Now see, here we have divided process into, this is secondary memory, this is main memory. Here pages will come into the frames, and we have a page table. So for each page of main memory, we have an entry in page table. Okay. Now, so total virtual address supported, virtual address size supported. What is the total virtual address size supported? Since for each entry we have a corresponding page, so number of pages will be equal to number of entry. So we have 8 million pages, which is equal to number of page table entry, and the size of each page is given over here. The size of each page is 8 kilobyte. So we have 8 kilobyte as the size of each page. So it is equal to 64. This is 8 into 2 to the power 20 into 8 into 2 to the power 10, which is equal to 64 into 2 to the power 30, which is equal to 64 GB, which is 2 to the power 36 bytes. So we have a virtual address space maximum can be supported of 64 GB or 2 to the power 36 bytes. So for 2 to the power n bytes, we need n length virtual address. So for 2 to the power 36, we need virtual address of size 36 bits. So answer is 36-bit virtual address can be supported. This question belongs to data structure subject and was asked in GATE CSE 2015 set 2. So the question states, which one of the following hash functions on integers will distribute keys most uniformly over 10 buckets numbered from 0 to 9, where I range from 0 to 2020. So this question is like this. We have 9 buckets: 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. Now we have all, we need to put all the numbers from 0 to 2020 into these buckets using these hash functions. So we need to tell in which of the following the key distribution will be most uniform. So first we have h of I equals to I square mod 10. Second we have h of I equals to I cube mod 10. H of I equals to 11 I square mod 10. H of I equals to 12 I square mod 10. Okay, so let us see one by one. So first one is h of I equals to I square mod 10. So what happens? Suppose we have keys here. Let us suppose we have I, then we have I square, then we have I square mod 10. Okay, let us also write I cube and I cube mod 10. Okay, so I is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I will also continue 10, 11, 12. But since the unit digit is same, unit digit will keep on repeating 0, 1, 2, 3. And as we are using modulus of 10, thus only unit digit will be considered. So 0 square is 0, 0 cube is 0, 1 cube, 1 square, 1 cube, 2 square, 3 square, 4 square, 5 square, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81. And here it will keep on repeating. See, 10 square is 100, 11 square is 121. So 0, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, 6 cube has 36 into 6, which is 216, 7 cube is 49 into 7, which is 343, 8 cube is 64 into 8, which is 512, 9 cube is 81 into 9, which is 729, and similarly it will continue. So what is I square mod 10? It is unit digit. So 0, 1 square mod 10, 1, 2 square mod 10, 4, 9. Here we will get unit digit 6, 5, 6, 9, 4, 1, 0, and it will keep on continuing. I cube mod 10. So we get unit digit which is 0, 1, 8, 7, 4, 5, 6, 3, 2, 9. Okay, and it will keep on continuing. Now see, when we have I square mod 10, then some of the numbers are repeating. Up till 9, you can observe. Here it is 9. 1 is repeating twice. Yes. 9 is repeating. Yes. 6 is repeating. Yes. 4 is repeating. Yes. So you can easily see that some of the numbers are even not present. 2 is not there. 3 is not there. 7 is not there. 8 is not there. So these slots 2, 3, 7 and 8 won't have any numbers. And the other slot will have more entries. 1, 0, 4, 5, 6 and 9 will have more entries. So it is non-uniform distribution. So I square will give non-uniform distribution even on multiplication. Now let us see I cube. Here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the keys 0 to 10, 0 to 9, it gives all the possibilities. One entry will be present in all. And when we will have I cube for 10, it will have 0 in unit place. 11 cube will have 1, 12 cube will have similarly 8, 13 cube will have 7. So which means it will have uniform distribution. So answer is h of I equals to I cube mod 10. As we have in I cube, the unit digit keeps on do not repeat from 0 to 9. They are distinct digits. So answer is option B. This question belongs to computer network subject and was asked in GATE CSE 2015 set 2. So the question states, assume that the bandwidth of a TCP connection is 1048,560 bits per second. Let alpha be the round trip time in milliseconds rounded off to the nearest integer, after which the TCP window scale option is needed. So alpha is the time after which the TCP window scale option is needed. Let beta be the maximum possible window size with the window scale option. Then the values of alpha and beta are. So we need to find the time as well as the maximum possible window size. So see, in TCP, when the bandwidth delay product, so we have a bandwidth delay product. So when this bandwidth delay product increases above 64K, then we will need the receiver window scaling is needed. Okay. Now, what is bandwidth delay product? So bandwidth delay product is the maximum amount of data on the network circuit at any point of time. It is the maximum data at network circuit at any point of time. Okay, and it is measured as round trip time into bandwidth is equals to our bandwidth delay product. Now note that this is not the time for sending the data, but it is just the time for sending the data without the acknowledgement. Okay, here we do not consider the acknowledgement. Okay. Now see, what is bandwidth delay product? It is round trip time into bandwidth. What is our round trip time? It's alpha. What is our bandwidth? Is 1048,560. It's bits per second, so we divide it by 8 to get bytes per second. Now it is equals to 64K. Then what is the value of alpha? Alpha equals to 64K into 8 divided by 1048,560. Basically cross multiplication. So we get it equals to 0.5 second, or we can write 500 milliseconds. Okay. Now see. Now when this window scaling happens, so after this point of time, receiver window scaling will occur. Now when this window scaling happens, a 14-bit shift count is used in the TCP header. So we use 14-bit shift count. Okay. So the maximum possible window size get increased. Initially the window size was 2 to the power 16 minus 1. This is the standard window size. So it get increased from this due to 14-bit shift it gets multiplied by 2 to the power 14. Thus it gets converted from, it gets changed from 2 to the power 16 minus 1 to this, which means it gets changed from 65535 to, what is the calculation for this? The calculation for this will be 65535 into 2 to the power 14. Okay, so this is our answer. So here the answer will be 500 milliseconds and 65535 into 2 to the power 14. So answer is option C. This question was asked in GATE CSE 2015 set 2 and is based on arrays. So the question states, a young tableau is a 2D array of integers increasing from left to right and from top to bottom. So it grows like this, from top to bottom and left to right. Any unfilled entries are marked with infinity, and hence there cannot be any entry to the right of and below an infinity. So if we have infinity, we can't have anything to its right and anything below it. On left and above we can have entries. Even in diagonals we can have. Okay. Now see. A Young tableau consists of unique entries. It must have unique entries. When an element is removed from Young tableau, other elements should be moved into its place so that the resulting table is still a Young tableau. Unfilled entries may be filled with the infinity. The number of entries other than 1 to be shifted to remove the Young tableau is. To remove 1 from the given Young tableau is. So we need to remove 1 from this tableau. So we need to tell how many entries we need to shift, how many shifts we need to make. Okay. See, so the algo for this is, if we are moving an item at a position array Aij, then the item that will come in its place will be the item which is minimum among. So we will get min among A, I plus 1j and A, I, j plus 1. Which means if this item is moved, then on its right and below it, the min of this will come over here. So see, 1 is removed. So min among 2 and 3 will come over here. So 2 will come over here. Now 2 is moved. As 2 came over here, so 2 is moved. So min among 4 and 5 will come. So min is 4. So 4 will come up. 4 will come over here. Now 4 is removed. So min among 6 and 12 is 6. 6 will come over here. Now 6 is moved. So min among 18 and 23, which is 18 will come over here. Yes. Now 18 is moved. So min among infinity and 25, which is 25 will come over here. Now 25 is moved. There is nothing on its right and below. So infinity will come over here. So what is our new table? So our new table will look like 2, 4, 5, 14, 3, 6, 18, 23, 10, 12, 18, 10, 12, 25, infinity, 31, infinity, infinity, infinity. So how many entries are moved? 2 was the first entry to be moved. Then we have 4, we have 6, we have 8, and we have 25. So 5 entries were moved. So answer to this question is 5. As we do not need to consider 1, it's given that other than 1. So other than 1, 2, 4, 6, 8 and 25, which are 5 entries are moved. So answer is 5. This question belongs to Digital Logic Design subject and was asked in GATE CSE 2015 Set 2. So the question states, a half adder is implemented with XOR and AND gates. A full adder is implemented with 2 half adders and 1 OR gate. Okay, so we have half adder. So using 2 half adders and 1 OR gate, we get a full adder. The propagation delay for XOR gate is twice that of AND gate. So propagation delay for XOR is 2 times the propagation delay of AND. The propagation delay for AND gate is, so propagation for AND is 1.2 microsecond, propagation delay for OR is 1.2 microsecond, and propagation delay for XOR is 2 times of AND or 2 times of OR, which is 2.4 microsecond. A 4-bit carry ripple, a 4-bit ripple carry binary adder is implemented by using 4 full adders. So we have used 4 full adders to implement a 4-bit carry binary ripple adder. The total propagation delay of this 4-bit binary adder in microsecond is, suppose we have 4 bits, A1, A2, A3 and A4, and B1, B2, B3 and B4. So here we will have sum and carries S2, C2, S3, C3 and S4 and C4. So these are 4 full adder circuits. So we will use 4 full adder circuits to implement this. Okay, so diagram for a full adder looks something like this. We have 2 XOR gates followed by 2 AND gates and 1 OR gate. Okay, so what should S1 wait for? See, S1 should wait for C1 to be ready. Let us assume this is S0, this is S1, this is S2, this is S3. Yes. So S1 should wait for C1 to be ready. Okay. And delay for generating C1 is, what is the delay for generating this? So delay for generating will be 1 XOR gate, 1 AND gate, because these are parallel. So 1 XOR, 1 AND and 1 OR. So delay for C is equals to 1 XOR plus 1 AND plus 1 OR, which is equals to XOR is 2.4, AND is 1.2, OR is 1.2. So we get 4.8. So after 4.8 microsecond, we get our S1. We get our C1. Okay. Now what is, so S1 should basically wait for C1 because S1 can't compute till we have C1. Okay. So delay for sum. What is the delay for these sums? So delay for sum is XOR plus XOR. We have 1 XOR, we have second XOR. So its total time is 2.4 plus 2.4, which is 4.8. So delay for sum is this and delay for carry is 4.8. Now see, but the scenario changes after the second adder. See, however, for any subsequent stage, we need to keep in mind that the output of the half adder is already there in 2.4 microsecond. So in a sense, it's already computing, which means the remaining half adder for each full adder is just waiting for the previous carry. So we have already computing this in 2.4 and we are just waiting for the previous carry, which when available can be processed in 2.4 microsecond. So next stage will take only 2.4 microsecond. Okay, because see, for the second adder, there the first XOR can be done even before the waiting for the previous output. The XOR can be done before waiting for the previous output. Okay, and so we can get sum in another 2.4 microsecond and carry in 2.4 microsecond. So which means all these three can be done in 2.4 microsecond, as we will use the pre-processing, and this will be done in 4.8 microsecond. So total time is 4.8 plus 3 into 2.4. So it comes out to be 12 microsecond. But see, here it is given that it is a ripple carry binary adder. So a ripple carry binary adder means that we cannot use the pre-processing, which means each adder must wait for the full output of the previous adder. So this adder must wait for the output of previous, this must wait for this must wait for this, and this must wait for this. So for waiting we will have 2.4 plus 2.4, 4.8 for sum, and 2.4 plus 1.2 plus 1.2, which means 4.8 for carry, which means that for each adder we will take 4.8. So total time is 4.8 into 4, which is equal to 19.2 microsecond, because it was given a ripple carry binary adder. It was if it was a normal adder, it would have been 12 microsecond. As it is ripple carry binary adder, so we have to wait for the previous output. So answer is 19.2 microsecond, as each adder is taking 4.8 microsecond and we have 4 adders. So answer is 19.2. This question belongs to Computer Organization subject and was asked in GATE CSE 2015 Set 2. So the question states, consider the sequence of machine instructions given. So we have 4 instructions: multiply R5, R0, R1, divide R6, R2, R3, add R7, R5, R6 and subtract R8, R7, R4. The above operation sequence R0 to R8 are general purpose registers. In the instructions shown, the first register stores the result of the operation performed on the second and third register, which means R5 will store R0 into R1, R6 will store R2 divided by R3, R7 will store R5 plus R6, and R8 will store R7 minus R4. The sequence of instructions is to be executed in a pipeline instruction processor. So we have pipelining with 4 stages: instruction fetch and decode denoted by IF, opcode fetch denoted by OF, perform operation denoted by PO, and write back the result denoted by WB. The IF, OF and WB stages take 1 clock cycle each, and the PO stage, which is the perform operation, takes 1 clock cycle for add or subtract instruction, 3 clock cycle for multiplication, and 5 clock cycle for division. The pipeline processor using operand forwarding. This is important. Operand forwarding is used from PO stage to the OF stage. The number of clock cycles taken for the execution of above sequence of instructions is. Okay, so first of all, let us try to draw it without the operand forwarding. So we have I1. Let us draw the timestamps over here. We have T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, T11, T12, T13, T14, T15, T16 and T17. Let us draw the instructions over here. We have 4 instructions: I1, I2, I3 and I4. So this is I1, this is I2, this is I3 and this is I4. Now let us fill the table. So first we have multiply instruction. So we have instruction fetch followed by opcode fetch followed by perform operation. This may take multiple clock cycles and all the other will take 1 clock cycle. Then we have write back. So we will have instruction fetch taking 1 clock cycle, opcode fetch taking 1 clock cycle. For multiplications, I1 is multiplication. So for multiplication we have 3 clock cycles. So perform operation take 3 clock cycles. Then we have 1 clock cycle for write back. Okay, so I1 is done. Now I2 can start the execution from here. Here it will not start as instruction fetch is going on. So it will start from here. Here we will have instruction fetch, then it will have opcode fetch, then it can't do perform operation as perform operation is going on for I1. So it will do perform operation from here. So I2 is divide. Divide has 5 clock cycle for perform operation. 5. So we have 5 perform operation: 1, 2, 3, 4 and 5, and then we have a write back. Now I3 is add. So we can't do instruction fetch from here, so we will start from T3. We will have instruction fetch. Now since there is a operand forwarding from PO stage to OF stage, thus OF stage of I3 cannot start till the PO stage of I2 has been completed. So OF stage will wait till the PO stage is completed. So OF stage will wait, and OF stage can start from here. Here we have OF stage. Now PO stage for add is only 1 clock cycle, and then we have write back. Now we have IF. So IF can't execute till IF is completed for the previous. So IF will start from here. This all will be wait. Now we will have opcode fetch. Opcode fetch can't be done till the perform operation is done for the previous stage. So opcode fetch will be done here. Then we will have perform operation, which take 1 clock cycle for subtract and write back. Okay. Now see, number of clock cycles are 50, but it is given that we can do the perform operation. It is given in the question that opcode forwarding takes place from PO stage to OF stage. Okay, so instead of 15 we can reduce the clock cycles. Okay. So what we can do is that we can make the PO stage produce the output during the rising edge of the clock. So if we have a clock over here, then PO stage can produce the output during the rising edge, and then we can make the OF stage fetch the output during the falling edge. So we can do PO and OF stage both in the same clock cycle instead of different clock cycle. So this would mean that the final PO stage and the OF stage can be done in 1 clock cycle. So what we will do is that, let me now erase some of the things so that I can explain you how it can be done in 1 clock cycle. See, here what will happen is that we will have PO, then write back. Here this OF can be done with this PO. So we will have OF over here. Let me use a different color. So we will have OF over here. Okay, this is OF. Now here we can have our PO stage, and here we can have our write back stage. Okay. Now see what will happen. 3 are done. Now here, this IF can't be done till here, but this IF can be done here. You can shift the IF to here. So IF can be done over here. In place of IF, we can do opcode fetch, because PO and OF can be done in the same clock cycle. So we can have opcode fetch over here. We can have perform operation over here, and we can have write back over here. So number of clock cycles needed are 13 because of operand forwarding from PO to OF, and they can be done in only 1 clock cycle. So answer is 13. We will need 13 clock cycle for executing this instruction in a pipeline processor with the stages IF, OF, PO and WP. So answer is 13. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015 set 2. So the question states, perform the following operations on the matrix. So we have a matrix A equals to 3, 4, 45, 7, 9, 105, 13, 2, 195. So it is a square matrix, 3 cross 3 matrix. Add the third row to the second row, subtract the third column from the first column. So determinant of the resultant matrix is. You can perform the operation and find the determinant by using the normal methods. But I will tell you a shortcut for this. See, what is our A? A is 3, 4, 45, 7, 9, 105, 13, 2, 195. First, try to see whether you are able to find a dependency between any row or columns. You can easily see that C1, which is column 1, is equals to 15 C1 equals to column 3, or C3 is equals to 15 C1, because 45 is equal to 15 into 3, 105 is equal to 15 into 7, 195 is equal to 15 into 13. Okay, or you can write 15 C1 minus C3 equal to 0. Thus there exists a linear dependency between any two columns, and whenever there exists a linear dependency, then determinant of that particular matrix is 0. So determinant of A is 0. Now there is another property. We can perform any number of row or column transformations. Like here we are performing the operation like R2 equals to R2 plus R3, and here we are performing C1 equals to C1 minus C3. We can perform any number of operations, but determinant of A, determinant of this matrix and the matrix that we get after the operation, let A dash, determinant of A and A dash will always be equal. So what is the determinant of A dash? A dash determinant will be equals to A determinant. And what is determinant of A? Determinant of A is 0 because we have found a linear dependency. like 15C1 equals to C3. Thus, the determinant of the resultant matrix is equal to determinant of the previous matrix, which is equals to 0. So answer is 0. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015 set 2. So the question states, which one of the following well-formed formulae is a tautology? So what is meaning of tautology? Tautology means it is true for all the possible values of the variables. Okay, so let us see all of them one by one. Here I will try to prove it with the help of examples. I will give you examples which shows that if LHS is true, then RHS is false, which means it is not a tautology. For A, let us consider we have a set X which consists of 6, 8 and 9, and we have a set Y which consists of 2 and 3. And the relation R is defined on X comma Y, which means X is divisible by Y. Okay, now see, what is it saying? It is saying for all X there exists a Y such that X is divisible by Y. For 6, yes, 6 is divisible by 2, 8, yes, 8 is divisible by 2, 9, yes, 9 is divisible by 3. So LHS is true. Now let us see whether RHS is true or not. There exists a Y, which means there should be a Y such that for all X, X is divisible by Y. Whether 2 divides everything or not? No, 2 can't divide 9. Whether 3 divides everything or not? No, 3 can't divide 8. Thus, we have proved that neither implies nor double implies the second one, which means this one is not true. Okay, so it is true in our example, but here we take Y individually. No single Y is capable of dividing all the X. Neither 2 can divide all, neither 3 can divide all. So it neither implies nor double implies. So it is false. It's not a tautology. Okay. Now let us see option B. For option B, assume we have the same sets and RXY means X is divisible by Y, and let me write it over here only. We have B, and SXY means X divided by Y equals to 2 or 3, which means the quotient is either 2 or 3. Okay, now see, if we have X at S, let us assume 4, 6 and 11. Okay, let us take X as 4, 6 and 11, and let us take Y as 2 and 3. So what it means? For all X, which means for all the values, if there exists a Y such that X divides Y, then the quotient will be either 2 or 3. Okay, now see, 4, whether 4 is divisible by anything? Yes, it is divisible by 2, so there exists a Y, and 4 by 2 is 2. Yes, it is true for 4. 6, yes, 6 is divisible by 2 and 6 by 2 is 3, which means S is also satisfied. 11, here for 11 is not divisible by anything, so it is by default true. Okay, which means LHS is true. Here 11 is not divisible, but since it is implication, so it doesn't make any difference, as false implies anything is true only in implication. Okay, now let us see the right hand side. What right hand side is saying? For all X there exists a Y such that, which means for all these values there will exist a Y such that X divided by Y is 2 or 3. Okay, for 4, yes, there exists 2. 4 by 2 is 2. For 6, yes, there exists 2. 6 by 2 is 3. But for 11, there do not exist any Y. So it is false. So false implies false is false only. So thus it is not a tautology. So A is not a tautology, B is not a tautology. Now let us first try to see D. For D, assume we have two sets, X as 8, 12 and 16 and Y as 2 and 4. What D says? For all X and Y, Pxy means for all X and Y, Pyx. Okay, so we have to define P. So we can define P as X divides Y. Yeah, we can define for all X and for all Y, Y divides X. Let us define Pxy as Y divides X. Okay, now see, it is saying for all X and Y, Y divides X. Okay, 8 2 divides 8, yes. 2 divides 12, yes. 2 divides 16, yes. 4 divides 8, yes. 4 divides 12, yes. 4 divides 16, yes. So it is true. Now let us see the right hand side. For all x, p by x. So p by x means, what is the meaning of p by x? P by x means x divides y, which means x divides all y, but it can't divide 2 and 4. Thus, this is false and not a tautology. Now only option remaining is C. So C is tautology. So answer is option C. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015 set 2. So the question states, a graph is self-complementary if it is isomorphic to its complement. For all self-complementary graphs of n vertices, n is a multiple of 4, even or a congruent to 0 mod 4 or 1 mod 4. Okay. So what is a self-complementary graph? See, if we have a graph with 4 vertices, okay, and some edges like this, okay, then the complement of the graph will be the one which will have all the edges, which is equals to edges in E dash G equals to complete graph of G minus the edges in G. So it will have all the edges which are not present. So it will have this edge, this edge, this edge, then it will have this edge. So 1, 2, 3, 4 over here, 5, 6 over here, and this one is, so complete graph has this 6 edges. Now 1, 2, 4 are present over here, 6 are 2 are present over here. So it is EG and it is complement of G. Now it is saying a graph is self-complementary if it is isomorphic to its complements, which means E of G plus E dash G is equal to complete graph. Number of edges will be equal to number of edges in complete graph. Number of edges in complete graph is n into n minus 1 by 2. Now since it is isomorphic, so number of edges will be same. So E plus E equals to n into n minus 1 by 2. So E equals to n into n minus 1 by 4. So number of edges in a self-complementary graph is n into n minus 1 by 4. Now since edges must be an integer, thus n must be divisible by 4 or n minus 1 should be divisible by 4. Or we can say n should be divisible by 4 means n is congruent to 0 mod 4. And n minus 1 is divisible by 4 means n is congruent to 1 mod 4. So answer is option D, congruent to 0 mod 4 or 1 mod 4. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015 set 2. So the question states, the second method is used to find the root of an equation fx equals to 0. So if we have an equation on x, it is equals to 0, then second method can be used to find the roots of the equation. It started with two distinct estimates, xa and xb. We assume that xa is the root and xb is the root. It is an iterative procedure involving linear interpolation to the root. The iteration stops if xb is very small, then xb is the solution. The procedure is given below. Observe that there is an expression which is missing and is marked by question mark. So here this xt equals to question mark is missing. Which is the suitable expression that is to be put in place of question mark so that it follows all steps of the second method. So this is our second method, it is given over here. And we need to find what should be the value of question mark. So what we do is, initially we initialize xa, xb, epsilon and n. N is the number of iterations and epsilon is the convergence indicator. Then we do fb equals to xb, I equals to 0. Now till I is less than n and fb is greater than epsilon, we do the following steps. Then we end the value. Then we have an if and the end of if. Now this second method is a standard method, and here what we are doing, putting in place of xt is basically we need to find the missing expression. So answer is option C. This is a standard method for finding the roots of equation. So answer is xb minus fb minus xa into fb divided by xb minus fxa. So answer is option C. It is basically numerical methods to solve an equation, and its standard answer is option C. This question belongs to programming subject and was asked in GATE CSE 2015 set 2. So the question states, consider the C program given below. So here we have the program. The value printed by the above program is. So we need to tell what is the value printed. So let us analyze the program. Here we have two global, this is a pointer variable and this is a skTop global variable. So we have global variables, pointer variable a, and we have sk top. Global variables are initialized to 0. Okay, so we have this. Now we have this skt function. It takes opcode and val as the input parameters. Then we have main function. So what main function does? It initializes an array b. This is a b array. Then it does a equals to b, which means a also point here. Then it does sk top equals to -1. So sk top becomes -1. Now it calls the function with -1 and 10. So we come over here, opcode gets -1 and value gets 10. Now here we have a static variable. So static variables are given the memory during the compile time only. So we have size and its default values are 0 only, and sk top 0. Now what happens? Here we have a switch on opcode. So opcode is -1. So case -1 will run. It will do size equals to value. So size becomes equals to value. What is value? Value is 10. So size becomes 10, and then it breaks. So and then it returns -1. So we come over here. Now what we do? We again come. We call it with skfunc 0,5. Now we call it with 0,5. So opcode is 0, value is 5. So here static variables are initialized only once, so they are not initialized now. Now we have switch on opcode. Opcode is 0, so case 0 runs. If sk top, what is sk top? Sk top is our 0. What is size? Size is our 10. 0 is less than 10? Yes. So it does a of sk top plus plus equals to val. So this is a pointer variable to a stack. So the stack of 1, so stack of 0 plus plus, which means it is a post increment operator. So stack of 0 becomes equals to val. What is our val? 5. So we push 5 over here and increment the sk top by 1. So sk top becomes 1. Then we break. Now we again come back to our main function. Now after coming back, now we call it with sk top 0,10. So opcode is 0, value is 10. Now we again come. These are static variables not initialized now. Now opcode 0. So switch on 0. Switch on 0. We come again to here. If sk top is 1, size is 10. 1 is less than 10. Yes. So a of 1, a of 1 becomes equals to val, which is 10, and it is post increment. So sk top becomes 2. Now we break. Now again we come to our main function. Now what happens? We then call the skfunc with 1 0 and 1 0 twice. So we call it with 1 0. Now the static variables are not initialized. Now we come over here. -1 fails, 0 fails, so we come to the default value. Now if sk top is 2, which means it executes, then it returns sk top. So it's pre-decrement, so it becomes 1, and it returns sk top of 1. Sk top of 1 is 10. So it pops and returns 10. So here 10 comes. Now it again calls skfunc with 1 0. So 1 0 default case runs. It returns a of sk top. So it decrements, returns sk top of 1, which is a of 1, which is 5. 5 is returned. 5 comes over here. Now we come over here and we print 10 plus 5, 15. So 15 is printed. So answer to this question is 15. So it basically pushes 5 and 10 to the stack, computes their sum, and prints it. So answer is 15. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015 set 2. So the question states that fx equals to x to the power minus 1 by 3 and a denotes the area of the region bounded by fx and x-axis when x varies from minus 1 to 1. Which of the following statement is are true? So let us see all the statements one by one. So first statement is f is continuous in the range minus 1 to 1. So what is our fx? So fx is our x to the power minus 1 by 3, or we can write 1 by cube root of x. Now let us see continuity at x equals to 0. So what is our left limit? Left limit is limit x tends to 0 1 by cube root of x, which is equals to limit h tends to 0 1 by cube root of 0 minus h, which is equals to limit s tends to 0 minus 1 by cube root of h. And if we put h equals to 0, we get minus infinity. Now let us see right hand limit. We have right limit. So it is equals to limit x tends to 0, 1 by cube root of x, which is equals to limit h tends to 0, 1 by cube root of 0 plus h. So it is equals to limit h tends to 0, 1 by cube root of h, which is equals to plus infinity. As left hand limit is not equal to right hand limit, thus it is not, statement 1 is false. It is not continuous at x equal to 0. So statement 1 is false. Now let us see statement 2. So statement 2 says f is not bounded in minus 1 to 1. Okay. So how we check this? So let us say that x at x equals to 0, the value was from minus infinity to plus infinity, which we have proved in the first part itself. Thus function is not bounded in minus 1 to 1. Thus option second is true. As we have already proved in option 1, that it goes from minus infinity to plus infinity. Let us see part 3. So part 3 says A is non-zero and finite. Okay. So what is our A? A is the area under minus 1 to 1. So let us break it to minus 1 to 0, x to the power minus 1 by 3 dx, plus we will have 0 to 1, x to the power minus 1 by 3 dx. So it is equals to 3 by 2, x to the power 2 by 3 integration minus 1 to 0 plus 3 by 2, x to the power 2 by 3, 0 to 1. It will be equal to 3 by 2, it becomes 0, and x to the power minus 2 by 3 is minus 1. So we will get 0 minus 1. 0 minus minus 1, which becomes plus 1, plus 3 by 2. 1 to the power 2 by 3 is 1, and it becomes 0. So we get 3 by 2 plus 3 by 2, which is 6 by 2. Thus it becomes a positive number. Thus we can say it is non-zero and finite. Thus it is also true. So second and third are true and first is false. So answer is option C. This question belongs to engineering mathematics subject and was asked in GATE CSE 2015 set 2. So the question states that x and y with the sets containing 2, so it has 2 items, x has 2 items and y has 20 items from y1, y2 up till y20. Distinct objects respectively, and f denotes the set of all possible functions from x to y. So what are the possible functions from x to y? So x can be mapped to any of the 20 items, x1 and x2 can be mapped to any of the 20 items. So number of possible ways are 20 into 20. These are possible outcomes. Now let us see favorable outcomes. Let f be a randomly chosen from f. So out of all those possible functions, f is a function which is chosen. The probability of f being 1 to 1 is, so 1 to 1 means one item will be mapped only to one item. So x1 has how many choices? x1 has 20 choices only. Now x1 will be mapped to any one of the choice. Now x2 can be mapped to any of the 20 items except that one item. So x2 has 19 choices. So the probability of 1 to 1 is 20 into 19 divided by 20 into 20. These are the possible number of ways, as x1 can map to 20, x2 can map to 20. Here x1 can map to 20 but x2 can map to only 90 because 1 has been used by x1 to maintain 1 property. So its value is 0.95. So answer is 0.95, or you can say 19 by 20. This question belongs to Theory of Computation subject and was asked in GATE CSE 2015 set 2. So the question states, consider the alphabet sigma equals to 0, 1, the null empty string lambda, and the set of strings x0, x1 and x2 generated by the corresponding non-terminals of the given grammar. x0, x1 and x2 are related as follows. So we have the equation for x0, x1 and x2. Which one of the following choices precisely represent the strings in x0? Okay, so let me first tell you a different version of Arden's theorem. Arden's theorem. we are going to prove that if R equals to PR plus Q, then it has a solution R equals to P star Q. I will tell you how. Here, see. What we have is, we have R equals to PR plus Q. Now R equals to, in case of R, place PR plus Q. PR plus Q plus Q. So we get PR plus PQ plus Q. Okay. Now again in place of R, place PR plus Q. So we get PR plus Q plus PQ plus Q. So it gets equals to triple PR plus PPQ plus PQ plus Q. If we keep on doing this, then in the end we will get R equals to many P's plus 4PQ plus triple PQ plus double PQ plus PQ plus Q. Okay. Now what we can do? We can take Q as common. So taking Q as common, we get, here null is left, here single P is left, here double P is left, here triple P is left, and so on up to P to the power n. So we can write it as P star Q. So here we have proved this. Now we will use this proof. Now see what we have. Now we have, let us take equation x1. So x1 is 0x1 plus 1x2. These are multiplication signs, not star or key enclosure. These are multiplication signs. 0x1 plus 1x2. Now let us put the value of x2 from below. 0x1 plus 1x2. So x2 value is 0x1 plus lambda. So we get equals to 0x1 plus 10x1 plus 1 lambda. Okay, now let us take x1 as common. So we get 0 plus 10 plus 1. Now let us write it as 0 plus 10x1 plus 1. Now let us equate it equals to R equals to PR plus Q. So if this is R, this is P, this is R, and this is Q. So it has a solution x1 equals to P star Q. 0 plus 10 whole star 1. Now what is x0? x0 according to equation 1 is 1 into x1. So 1 into x1. What is x1? x1 is this. 0 plus 10 whole star 1. So this is our answer. x0 equals to 1 into 0 plus 10 whole star 1. So answer is option